Good morning, everyone. Hello, good morning, everyone. Am I audible, guys? Okay, okay, awesome. Chat is enabled, yeah. Great. Another day, another weekend, another day for learning. Cool, cool. Let's give a couple of more minutes to join other folks. And meanwhile, whosoever have joined, you can tell me the progress. Yeah, few folks are saying like, have you just woke up? Yeah, actually, yes. Yeah, and for the assignment, don't worry, guys, right? At least try to complete it as soon as possible, right? So that like I can also announce the winners for this one, right? So that is the thing. So please make sure, right, you upload it as soon as possible. It is done, right? So for the assignment at max, you can just take this week, right, to complete it. And after that, right, definitely we will announce the winners. And today, basically, it is about completing the remaining topics of Hive. So today Hive will be completed, and so tomorrow's class will be taken by Sudhanshu itself, and we will be starting with the HBase. So HBase basically our NoSQL database. So we are trying to cover the all fundamental things, right? Fundamental as in which can help you to even start with the projects. So HBase, then I will be teaching the Kafka part, and after that I'll be taking classes for the Spark, right? And then there will be Airflow and all those things, so that at least within 3 months, this is our target. Yeah, Cassandra will be also there. I will be teaching Cassandra as well. So 2 3 NoSQL databases we want to cover for you all. So this is the target, so that just after 3 months you are at least in a good position, so that if we are giving you some projects, right, at least decent projects where you need to pull data from some sources, then process it via Spark or Hive or anything like that, and then dumping it to somewhere, and also you can say connecting with different kind of databases, right? So all those things will be there, and SQL will be also there. I will be teaching all those things, guys. Don't worry, we have enough amount of time. So whatever is listed in the syllabus, everything will be covered, right? So don't worry, don't worry. So yeah, don't go with the sequence which is mentioned in the syllabus. So right, that was our first attempt. So I missed few things to rearrange over the portal, but we will make sure we are teaching in such a way so that your dots are connected, right? Nothing, let's say, just after MySQL, I'm directly jumping to the cloud part. That is why, right? Before even jumping onto the AWS also something I will be teaching. So I don't want you to feel lost, completely lost, like even when we create pipelines on the AWS, correct? So that is how we will be taking the baby steps, covering all these fundamentals, then the SQL part, then the NoSQL databases, Spark will be there, Kafka will be there, Airflow will be there, and then something cool, we will be starting with our AWS and Azure related things. So sounds good. For the lab environment, we are working really hard, guys. We are, honestly speaking, I am seeing like how uh, like the team is working really hard from the backend to make it live for everyone, because as I said, there is not only one batch, there are so many learners, right, in our different batches. So we need to like make it enable for each and everyone. So team is working on it, and don't worry about it. As soon as it is done, you will get the lab environment access. So at least for couple of weeks, if you are able to practice in your local, that is completely fine. Else just listen to the lectures and tutorials, and once the lab environment is available for you, boom, just practice everything which you have practiced so far on your local. Cool. So we'll just start in 2 minutes with our today's topic for the Hive. Hey Abhishek, I can see your message. So see, this is not an simple task where just right in a few seconds everything is integrated and everything, correct? So things takes time. So have some patience, because this was something which was not even included in the syllabus and all these things. We tried our best to bring it up in the ecosystem so that smoothly you guys can practice it. So have some patience. As soon as this will be ready, right, it will be provided to you, the lab environment and all. And so far you have set up all the things in your local, so just focus on that one, because those things are also very much important. If you don't even know how to set up Hadoop, Hive and all these things in your local, then you will like you will hustle a lot while debugging the things itself. So just have some patience. As soon as it is ready, it will be available for you, right? Our team is working day and night to make it live, right? So understand from the developer perspective, it is not something which is a 1 day task or few hours of task to complete the things. And for anyone who is joining for the very first time, again, don't worry, you can quickly pick it up. Just watch the previous recordings, whatever we have taught so far, all the assignment related things, all the script related things, everything will be available for you, right? So don't worry about it. Just use your time, and you will pick it up quickly. All right, so let's start. Just a second, let me share my screen and let me know once it is visible to you all. Just a second. Let me know, guys, my screen is visible or not. Is it visible, right? Okay, awesome, cool. So today, first thing, what we are going to start with, that is the UDFs in Hive, right? So UDF, what does it stands for? So UDF is equivalent to user defined functions. And guys, today's class is very, very much important. Why? Because few of the amazing concepts of Hive we will be covering today, and those are even very much important from your day-to-day activities as a data engineer, right? Or a big data developer, or whatever profile you are working on. And also from the optimizations perspective related questions in the interviews, right? This is something which is gonna be super important. So just uh, like be attentive in the class and learn all these things. So user defined functions, so simply, right, when you talk about any programming language or any other thing, right, so there we have few libraries or few inbuilt functions, right? So simple example is, let's say, in Python programming language, right, if we have some array or list, right, where few elements are written, 1 2 3 4 5 something, right, then we can have multiple functions, let's say, right, sum and let's say min, max, right? So these are something which are already, you can say, predefined functions or already built-in functions, you can actually call it, right, which are already available in some libraries, right, and are even coming with the compilers, right? So that is something which you can use, and those are known as the built-in functions. But when we talk about the user defined function, so what is actually mean, like any custom function which is written by you based on your use cases is something which will known as the user defined function. So same in the Hive, we will be having data in the tables and then we will query it. So there could be multiple use cases where on the runtime itself, let's say when we are doing a select query, right, we need to do some computation, right? So the need of UDFs could be custom functions for runtime manipulation, right? So this is the actual need of our UDF functions. So custom functions for runtime manipulation. And simple example, let's say if I give you a very simple example, correct? So let's say you had employee table, right? Employee table where you had two columns, simple again, name and salary, correct? So these are the two columns, and again, let's say members 1000 and Rahul 2000, correct? So let's say this is your Hive table, correct? Hive table, and what will happen? You can simple do a select star from this employee table and you will get all these records. Now let's imagine you have a use case, or being in company you want or you need to apply an automatic rule as in let's say this is the quarter for promotions and increment, and in your company there is a fixed band, let's say each employee salary will be incremented by the 20%, correct? So now you want to generalize this thing, generalize as in you want to have any custom function, because now in Hive there will be no function as such where you can pass this salary value, right? And just exact 20% of it, right, will get added into it, and you will get the final result, right? So that is something which will not happen, correct? So for that one, what you need to do, you need to write a user defined function, correct? So user defined function, what will happen there? You will pass these attributes, right? Or you will pass these columns as an input to that user defined function, and user defined function will do some calculation on top of it and will send you the result, right? Now the question is how this processing actually happened. So first, let me draw something and I will show these things like practically, then you will get more clarity. So let's say this is your UDF, for an example, salary increment dot py, right? This is your Python file or Python program where one function is written, right? And that function, what it does, it will basically accept this line, right? So once you will fire this select star something something, so at this star place we will be writing few keywords or statement which will use this UDF function, and within that UDF function we will pass our input column names, which this particular script will accept for the manipulation, right? So here what will happen, line by line execution, right? So this was our employee table, right? So employee table here, name and salary. So within this salary increment dot py or this Python program or Python file, Python code, you can say, there is, let's say, one function name as 20% hike, right? One function is there, 20% hike, right? Just give an example. And even if you don't want to create a function, so you can write a simple, all those lines you wanted to write in this function in this Python file itself. So this Python file even will accept the parameters as an input, right? So after doing this thing, how it actually gets computed. So again, let's say Shashank was written and 1000, and here Rahul was written, it was 2000, correct? And this function logic was pretty simple. Whatever this salary column, because we need to increment the salary, so salary column will be passed, right? So here what will happen, the formula will be simple, very simple. You can say new variable will be there, let's say new salary, and how it will get computed. So whatever salary you have, salary plus 20% of salary, right? So this is how your new salary will get computed, and it will, this script will send back the result to the Hive engine itself, correct? So now to understand more about it, that how this script is working. So again, as I said, this script, right, which is written here, it will accept your input line by line. Salary increment dot py. So this data you have, it will accept line by line your inputs, correct? And after that, it will do the processing. So first, what will happen? And the statement we basically write, that is pretty simple. So here something like a transform keyword we will be using in order to apply this function, right? Transform and the input column names, correct? That will be passed, and after that we will provide the path, full path where this script is particularly stored, and then from our employee table, correct? So that is why this transform keyword is being used, because we want to do some transformation on this particular column and even multiple columns, correct? So that is how it will be done. And here salary increment dot py, what will happen as soon as you write this statement, so it will try to pull all the records, and these records won't be displayed over the screen instantly. So this line as a stream will go to this salary increment dot py, right, as a stream. Basically, what does this stream means in the big data world? Stream means any particular system which is generating the events or the records, right, frequently or in real time, event by event processing, right? Then when we say that something is happening on the basis of event by event processing, then we will call it as a stream of event. So first this line will be passed, and after that this line will be passed. So as a stream, this will keep on going to this salary incremented.py file, or your any UDF, right? This is not we can say only this UDF can only be written in Python. This UDF can be written in Java as well, in Scala as well, right? You just need to add those files in your Hive queries, or while executing any Hive query from the terminal or the shell, wherever you are executing. The way right, when we were working with the Surdays, so there we imported few libraries in the Hive shell. So similarly, since this is a custom code, so anytime in the Hive, if you are writing any custom thing, that needs to be packaged and it needs to be imported in your Hive shell whenever you are querying the things, right? So that is how this stream will go to this function, and the calculation will happen, and you will be getting the output for the same, correct? So for the theory part, there isn't much to discuss in the UDFs, because UDFs, again, we know it's a simple custom function. The main thing is to understand that how this needs to be done, how this needs to be implemented in Hive, and how it will get executed. So that is something which I will show you practically. So this part is understood, that what is the need of this UDF and how the UDFs will actually process the records. Is it clear, right? Cool. For the processing part, I'm going to show you the practical, right? So you will get the complete idea that how it is happening. And here this transform keyword is needed, right? So transform keyword is needed because we want to process few columns separately, right? So now let me show this thing to you, and I will just let me show this thing basically, and practically you will get more idea that how this transform and other keywords are working. So that will give you the better visibility. And even for the today's class, right, whatever notes or whatever assignments, so today the best thing is that at the end of the class I will be giving you the two good assignments of the Hive, so you need to complete that one as well. So that is why in the chat box, right, I am pasting the GitHub repository. Even today's class, whatever script I will be writing, that will be added in the GitHub repo. So make sure you have it with yourself, right? Now let me do this thing. So session is closed. Just a second. Let me log in into that. Okay, so first what we will do, we will write a Python function, and in that Python function, what will happen? We will simply create that function will, what it will do, whatever value you are passing into it, right? Here it will simply, it will multiply by 1,000, let's say, right? It will multiply it by 1,000. That is the simple thing we will try to do here, right? So for that one, let's start our Hive first, and we will check our data that what all things are there. Okay, so use Hive class 4, show tables. So this is the data we already have. Set hive.cli dot print dot header equals to true, right? So in the last class we created these data sets and we were using it. So let's try to print it, and we'll try to use the same data set for this UDF part and do the manipulation on few of its columns, right? So let's see what all columns we can use. Correct? Okay. So we have this order number, the order quantity, right? So let's say order quantity column is something which we want to use, and we want to, let's say, increment it by 10 or something, or let's say we want to multiply it by 100 or something like this, correct? So let's go back one more time to this, and let me pull my script. Not this one. Yeah, Vim, Python. I will tell you that two things are written. So I will first make sure you get it. Just a second. So Vim, new Python, UDF. This one, multiply udf.py, right? So I will explain this code part. So bad indentation. I will explain each line so that you get the complete idea that how it is working. So don't worry that I'm not able to get something or like that. Don't worry. Cool. So first, let me write that script. The script is simple. I will explain that how this whole part is getting executed. The simple, you can say line by line execution, correct? So line, and here what value we will be passing to it, that will be quantity, right? So quantity integer, simple line, right? After that, what we want to do, we want to multiply it by 10. Quantity equals to quantity into quantity equals to multiply by, let's say, 10. Yes, correct. So this is, and after that, let's print it. Print str. Okay, so first let me save it and then let me explain it to you. Cool. So this is our simple Python script. Okay. So here what will happen, right? If you can see this Python script, uh, nothing like a rocket science to understand here, right? A very simple step. As I said, if you look at any programming languages, right? So there are, you can say, let me first even execute it, then you will get more idea. If I execute and run this program, then how this will even happen, right? So you will get more idea about it. Then it would be much better to run it. Python. So here you can see, right? When I typed 200, we received the output 2000. Is it visible to everyone, right? And the thing which we have written, correct? The thing which we have written in the script, which is accepting something and multiplying it by 10. This is clear, right? How this part is actually working. And now if I type 300, we will be getting 3000. If I type 500, we will be getting 5000. This is clear, right? How it is happening, at least on the terminal, right? We are giving some input and it is printing some output, right? Now you can see this program is never ending. This program, right? It should have been terminated as soon as I would have done some operation, because I have provided my input. It has published the output. It should have terminated, right? But it is not. Why? Because this program is running, basically you can say it is listening to the stream, right? And how this stream part is actually working. Now in my terminal, right, if I do something like this, control C, right, or anything like that, any interruption, then this script is basically has stopped executing, correct? Now if I go back to my this script, right? So here what you can see, this import sys is basically nothing, a Python library, because it is a very common use case. Let's say you are working with Java code, Scala code, Python code. So there will be multiple use cases where you need to accept the input from the user from the terminal itself, right? So in order to deal with those kind of commands and functionalities, we need this sys, or you can say system library, imported in the Python code, right? Next line is, you can see, for line in sys dot std in. Std in means standard input. In our case, what we are doing, our standard input will be the keyboard, from where we are simply typing something on the terminal, right? So when we are typing it, that is why, right? For loop, while loop, right? These are the basic concepts of programming. So what happens there? Let's say even what you have done, you have like you have written any code and it will accept the user inputs from your side, right? So if you have written this for loop and while loop, so they needs to follow some condition. If that condition is not achievable, they will run in an infinite loop, right? Until unless any external interruption is provided, right? So that is the same thing we want to apply, because when we will write the select star query, as I said, what will happen? Let's say there are 1000 record, 1 million record, 100K records. Those records will come as a stream to this Python code one by one, right? So the thing which I did, I started my Python program by writing Python and my script. And after that, it was blinking on the terminal, and blinking means it was expecting some input from my side. And as soon as I written 200, that input was captured by this thing. Says .std in means whatever input which has been written on the terminal, just read it. And when we pass any input from the terminal, right? So that is something which will be read as a string, even though if I have written 200 there, but that will be not treated as an integer in this Python script. It will be treated as a string, and after that we need to do our own manipulation by changing its data type based on our use cases, right? So this part, I hope this part is clear, that how we are reading the inputs from the terminal and how this input in a loop will come into this Python function when we will be using this UDF in our Hive queries. So this part is understood, that how this code is reading lines, like line by line inputs from the Hive with the help of this library and these parameters. Is it understood? Okay. Cool. And don't worry about the how we will be reading the data. That syntax I will be writing and you will get the complete idea, right? Here I'm just explaining how this Python part is working so that you will be able to relate it when I will write the complete syntax on the Hive terminal. Correct? So now this is a simple, you can say, as I said, whatever we will be writing on the terminal or whatever this line will read from the terminal itself, that will be a simple string. Even if you have written 200 or let's say 10.5, it will not be treated as a, its standard data type like integer or float. So for that one, first thing what we are doing, right? What we are doing, since it was accepted as a string, we are trying to just remove the, you can say, new line characters or any kind of these special characters from the string itself, right? Because that is very common. Sometimes those new line characters and all these things can actually come into the string itself, right? So how I can explain it? Yeah. So if I am here, let's say there is some string you have written, right? So string, because when these strings are actually get stored in the memory, right? And after that, let's say you had one new line character or something like that, just this whole input you provided and hello. So this is quoted in the double quote. That means this whole part, this and this is part of one single string. So in the computer science world, how this new line, as soon as you hit enter from your laptop or machine keyboard, right, you just go to the next line. So in the computers, right, or the file systems, this new line character is being mentioned by this one \n, right? And similarly, there is another, you can say, special character \r, right, for the characters. Correct. So these are the special characters actually. So whenever we are accepting the raw string, what should we do? We should apply this .strip function, right? .strip function. And what will happen? It will just try to remove all these kind of special characters from this input string so that it can become a simple plain string, right? Now, if I come back to this one, after that, what we are doing, since now this line is basically, you can say, line is basically now converted into a plain string, right? Plain string has been converted. So when I executed that script, the first input which I provided, it was 200, right? So initially, since it was 200, its data type was str, right? And where I stored it, I stored in this variable line 200. And since this is a very plain string and it didn't had only, you can say, new line character or any kind of backslash r, backslash t is basically for tab, right? So let's say in your string you have written in such a way, let's say Shashank, and from in your word document you hit a tab. So tab means basically 4 spaces or 8 spaces, whatever configuration you have, and then Mishra, right? So to represent the tab in the file system, backslash t will be used, correct? And you will see few amazing things when I will explain it in more depth, right? So don't worry. So as soon as I read this one 200 str, so what happened, this 200, you can say, was stored in this variable line and its data type is still str. But now I want to do these multiplication operations, so obviously I need to convert this line variable or convert this value integer or float, whatever, like let's say input you are taking, right? So for that one we need to do the typecasting part. So here what I am doing, this line was holding the value 200 as a string, and now I am just doing a typecasting. So int means whatever value I'm passing to it, it will convert it into the integer, right? And now this integer value 200 will be assigned to this variable quantity. And after that, what I am doing, simple programming we are doing, it's very logical to understand, nothing, again I'm saying nothing complex or a rocket science. So here quantity equals to 200, so this line equals to 200, its data type was str, and after doing the typecasting we assigned this 200 to variable quantity, and now it is integer. So now we want to do the manipulation, correct? So how I can do it, I can do some manipulation on this variable and store the same result back to this variable. So what I did, quantity equals to quantity into 10. So how this will get computed, 200 into 10, and 2000 will be again assigned back to the quantity variable, right? So now the new value of quantity is 2000. And after that, what I am doing, simple print it. And that printing is something means the output is being sent from this script, or basically displayed by this print statement over the screen. So I hope now this step-by-step process of this execution is pretty much clear to you, that how it is actually happening. Great. Now quickly I will show you that. Yeah. So this is a good question. Somebody asked that why we convert this result into a string, right? So again, for this one, you will get the idea. Right now, you think that this is something which is simple string, correct? So this is something which needs to be taken care by the output, right? So that you will get more clarity, right? Just hold on for a few seconds. When I will give you the another example, that will be clarified that why this is there, correct? And here, right, we were accepting the inputs as a stream, and after that we did the manipulation, we are printing the results. Now let me show you that how this is being done and how this will get computed, right, in the Python, and how to use these UDFs, you can say, in Hive. So first let me place this file in my local temp, multiply UDF / tmp and then Hive class, right? So now this file is there and I will start my Hive. So use Hive class 4. correct? And show tables, this one, set hive.cli.print.header equals to true. So first let's look at the select again star from this table. Limit, forgot to add the limit. It can be stopped, but I didn't want it actually. Limit 10, right? Awesome. So here we have this quantity ordered. So let's see the few records. So select quantity ordered from this table and limit 10. So 30, 40, mostly, right? These things, correct? So mostly you will see, most of the time you will see the numbers or the quantity orders in this one, right? In the double digits. So if we are applying and multiplying these things by 10, so at least in hundreds digits, we will be seeing the output. So first, let's try to do these things step by step. What we need to do, the first, we need to add that file, right? Add that function into this Hive shell wherever you are executing. So add file /tmp Hive class and multiply udf.py, right? So here we can see this resource added, means this script has been added into our system, right? Now select transform, right? This is the first keyword we need to use. So select transform, and this transform, what it will expect from us, it will expect to mention those columns which, right, we want to pass in that Python script, right? So the way we have written our Python script, it will be only able to handle, right, one attribute. Let's say even as a stream, I pass 2-3 columns, but right, I haven't written any split statement there. What I am assuming in the Python script, I will be only getting one value or one column value as an input. On top of that, I will convert it into int, float, and all those things, and will simply display it over the screen. That's how. So select transform, and the transformation we want to apply on which column? This column of the input table, right? So I have passed this thing. After that, another keyword we need to write using. What we want to use? We want to use the Python script which we have added into our Hive shell, right? So for that one, I need to write this simple statement which I written Python and you can simply read it, right? This statement which we have written, it is a self-explanatory that how these UDFs are going to work. So select transform this particular column using this script, right? Very simple. If you just read it, even you will get the idea that how this UDF is going to work here. Select transform. Transform means this is the input column on which you can say we are going to transform it. We are going to manipulate its value, correct? And with the help of what? With the help of this Python script, because here we have written some logic which will handle this one as a stream of records, and it will do the computation and it will send it back, right? So that is how it is. So select this thing using Python, this from our table, and after that just let's apply the limit 10, right? And let's execute it. And using after that, so this column, right? Just a second. Yeah. So now this is the transformation, or basically transformation we are doing on top of this column. So whatever will be the returned output, like means whatever was getting printed, we use that print statement. Whatever was getting printed, we would give a different name to it. So for that one, after this one, using whatever our script, so we will provide as, right? As means a new alias. For that one, we will use this keyword, and here quantity multiplied, right? Quantity multiplied. This will be the return, or whatever will be the return output, we will store it in this column, quantity multiplied. And let's run it. Right? It has started executing. Cool. So you think, right, our output is correct or not? Can we see the results multiplied by 10? Right? So are you getting the idea, right? That when we launched that above statement, how it would have processed it. So separately, we were executing our Python script, where we started Python script, and one by one, we were giving input to it, and it was doing the same thing for us. But here we use that script and we passed all those records, right, to this script, and it computed, and it simply just returned the output. Yes. Now the question is, I got this question, right, in this chat box, that how we can even add and work with other columns, correct? And this is something, right, which needs to be taken care and which needs to be understand. Right? I know you are a little bit confused that why, like, we have used the string. You will get the idea, right? Just hold on for a second, correct? But still, at least this moment, baby steps, you got the idea how to create the Python script, how to add it into the Hive shell, right? And after that, like how to even execute and how to use that print statement and all these things, like select, transform will accept the input numbers, right? And after expecting the input numbers, how it will using the script, and after that, where and which column it is simply using it, correct? So first, let me create a new file in the GitHub repo, so that, right, you can just play around it. Let me do it right away. Okay, so add file, create new file. This is our Hive class 5, and let me add the script. Let me add that statement. So this is, so this is the step we have added, and let me just push it, and I will add that script as well, right? I will add that script for you. So create a new file and multiply UDF dot py, and let's pick it from there, right? Just do exit and vim multiply UDF. This is our script. Simple as that. I will remove the comments part so that you don't get confused. And this is also done. And again, I'm sharing the GitHub repo link. So you will find the statement in the Hive class 5 txt, or simple, I guess, Hive class 5. And it should be a statement to execute, Python UDF. I will add the statement, add #add UDF in Hive shell. Right, let me add that statement. So here is our statement to add it in this one. So this is also done. Let me again share this one, Hive class 5. Cool. So this part is done. Now let's try your doubt, means how it will be taken care and how it will be done, right? So again, I'm starting it. Hive, let me open another terminal, so that will be pretty quick. The back and forth part, I need to close the terminal again and again. This one, quickly. So use Hive class 4, set hive dot cli dot print dot header equals to true. And quickly, I will add this file first, and I will show you that if we pass more than one column, then what is going to happen. Correct. So for that one, again, let's quickly check what other column we can use. So select star from our input table, which is this thing, and limit 10. Right, so order number is also there. Let's try to pass it, right? Let's use the same transform statement and try to pass it in this one. Let's see what will even happen. Okay, option, okay, quantity ordered, comma, order number. Let's run it. Let's get executed, and then I will show you if that can be done or not. So you can see the error, right? It has break. Cool. And you can see this error. An error occurred when trying to close the operator running your custom script, right? So that means something which this particular map reduce task was not able to process. And why did even actually happen? Correct. So see what happened, the way we written our Python script, what it was expecting from us, simple things, right? Now there, that is something where you need to focus. What our Python script, in our Python script, what we did, we wrote simple steps for line in sys dot standard input, and after that simply line equals to line dot strip backslash n backslash r, something, correct. So now what happened when I wrote this thing, transform, let me write another part as well. So quantity, after that how I did this quantity part means integer and then line, and after that quantity equals to quantity into 10 and then print our result. Simple, right? That's what we did. Correct. Now when I wrote this part, the quantity, this transform part. So what actually happened behind the scenes? So here when I written transform order number comma quantity. So when I written this program, so as a stream, two values, right? As a stream and as a string, right? Means whatever value is flowing from this part is going simply as a string. So what would have been passed? Let's say order number 1 and some, let's say this 100. Correct? Something like this. This was passed. So first line will read it, right? No problem. In this step, there will be no failure from this script. This line will be also working fine because here this whole part, right? This whole thing will be treated as a string. This whole part, whole line will be treated as a string. So this will be also implemented fine. Now things will actually break at this moment, right? Any guesses why the things will break at this moment? Because if you are able to answer this one, that means you have got the idea that why we cannot pass multiple columns, right, from our Hive statement until and unless we have handled it in our Python script. Why this script break at this point? Any idea? Yes, yes, yes. Correct, correct. You are getting the complete idea. So here, why actually things break, right? Because what we were expecting that this line will be a kind of a string which will hold these numerical values, right? That is how we implemented our script. Correct. And our script will work fine if we are passing our input in this manner. Means although let's say it is a string, but a string which is holding the numerical values, then this typecasting will work. If let's say I have written Shashank 120, this is the string, and what I am doing, I am just trying to convert it into integer, right? Will it happen or not? If I apply this function, right, will it happen if I am passing this thing to the typecasting function? No, correct, right? So that is the simple idea. So if you want to pass multiple columns from your input Hive statement, right? So those needs to be handled in the same manner, in the same sequence in your Python script, else you will always get the errors. Understood? I hope now this would have cleared the confusion that why it was only accepting one input and why it only converted it. Because if we pass, right, because our Python script is accepting everything, right? This part is the whole, you can say, in this transform function we passed two columns, and the two columns means will hold these values, order num1 as a string, and then this numerical value, and this one will go as a string to our Python one. And here if I am applying this part integer and then some value, right, or let's say Shashank 120, then it will break because that cannot be typecasted. So how gracefully it can be handled? So let's say our input string was this thing, order number 1, and let's say something comma or 100. So in Python, after reading this input after reading this input string, if I'm able to extract this value separately, and I'm able to extract this value separately, and if I can store this value in variable v1 and this value in variable v2, then I can manipulate those two values separately, right? That is how it will be done moving forward. So the next part, right, which we are going to look at, that is how it will be done. Order number, see Ayushi, here I'm giving you the explanation. Let's see, it's not necessary that order number will be always an integer. So let's take an Amazon example. So here your order number, let's say, can be Amazon 001, right? This is not a string. I'm just explaining it that even how this can work. Correct. So now the point is how to even deal with the multiple columns. And one more challenge, right? One more challenge with this part. With these, you can say, let me show it to you. Whenever we will be using this transform or the custom UDFs in our script, right? So what will be the challenge? Let's say if I want to do this select star, and after that I want to have one derived column, right, which will be derived by our custom UDF, and let me run it, right? It will instantly get failed. So this is also something which is not doable. Whenever in our select statements, if we want to select particular columns, right, here I did a select star. Let's say separately I wanted to select order number, and then let's say city, country, and then comma this you can say custom output or this modified or derived column from this Hive part. Then we will, like this is something which cannot be done. For that one, you need to handle this thing in your custom string itself. Let's say what you want to do, you want to pass, or you want to pass the inputs in your Python script, right? And in this Python script, you will pass 4 columns. So let's say those 3 columns you wanted as a select statement, and only on the 4th column you wanted to apply the transformation. So that is how you need to actually do it, right? So I will tell you that how this will be done, and again we will see the same example how to pass those multiple columns. But remember this thing, select star or select any particular columns and then comma applying this transformation, right, or using this UDF is not going to work. You need to handle those columns in this particular script itself, which you even want to be present in your final select statement. Correct. So let's try to do that. Correct. So just a second, describe. This thing. So order number. So now what I am going to show you, I will write another custom script, right, where I will try to pass 3 columns. 3 columns, one will be order number, right? Second will be, you can say, the country, correct? And third will be the quantity. ठीक है, quantity ordered, and I will try to manipulate on something, right? So what I am expecting here basically, so I want to do something like this. Select, let's say country, comma, order number, and then, right, transform on quantity, correct, from something something. But this is something which is not doable if we are using this any kind of custom UDFs in our Hive statements. So how I need to tackle it in my Python script, whatever these columns I want in my final select statement, I will make these two columns part of my transform method itself, and these two things will also get passed to our custom Python script, and there it will be tackled manually. So transform, so here country, then order number, and then quantity, right, from this, correct? So that is how I want to take care of it. So I need to write my script in such a way so that it is able to simply accept these three parameters, and it will do some manipulation on top of it, and it will send it as a result, right? Now in this part you will get the idea that why we will be using that print statement and why everything was supposed to be converted into the string. Because when Python, right, when Python was accepting everything, it was accepting as a stream of string. So it is Python script or custom UDF's is responsibility to even deliver the result, in the form of the stream, and in the select statement those individual output columns will again converted into their respective data types, right? So I will show you that how it will be done. So first let's try to write the script. So cp multiply.udf, and here I will name it like the many column udf.py. So vim many column udf.py, correct? So now first statement gonna be same line. We will try to do this \n/r removal after this one, right? Now this is something which will come at the later point of time. So what we are going to do now, I will write something and I will explain it, that how it is even working. So quantity, country, comma, order number, comma, quantity. And after that, order num will get converted into the integer, because its original type in our Hive table is integer. Country is string in our Hive table as well, and here it will also get readed as a string, so we don't need to do any typecasting for it. And quantity will also get converted into this integer, right? After that, what we wanted to multiply quantity by 10. Let's say this time it will be by 1000. Correct. So quantity was done, and after that we will simply make our resultant string. Country, then str order number, and then quantity. Print a result. So line country comma this country order number quantity split by tab, order number equals to integer order number quantity 1000, then join country comma str order num comma str quantity, and then it will be stored in result, and here it is. Right now, first let me this time do this complete execution for part for you, then it will be understood to you. So let me first do that part. So now cp many column mapping /temp Hive class. Right now here what we will do, we will add this new file, new UDF file. Wrong path. Hive class. Right. So now this has been added, and this time now where is our select statement. Cool. Now just keep an eye on this statement, that how it is going to work. So in our Python script, right, if I go back here, if I simply open our Python script, cool. So first thing, we are reading all these three lines. We are reading like every line. In each line, there will be three values, right? And every value will be in the form of a string, because as I said, string will be accepted as a string, correct? Now after that, we are applying the split part. So let me quickly explain it to you, that what does it mean. And I guess very simple to predict, nothing difficult, but still let me explain for everyone who don't know about it. So here what I have written, this statement, right? Simple, this statement, that hey, select, and in this transform function, pass these three columns, country, right? And then order number, and then quantity, or order quantity ordered, correct? So now if we are doing this thing, so as I said, it will be sent to the UDF function, right? As in the form of the string, correct? So what will happen here? Select, let's say our country was USA, and order number was, let's say, 1002, quantity ordered 200. Another record was, let's say, India, right? 1003, and let's say quantity ordered 300, correct? Now this line and this line, correct? This will go as a string to our function, correct? So now let's say this line is coming as a stream. So as per our script, right, whatever will be the output will be coming, it will get stored in this line variable. So at this moment, what line is containing? Line will have this value, USA. And see here what is happening, that here you will see this split function happening on the \t. So although right on our terminal we are firing this select star, right? So even on this output terminal, right, you can see, although let's say we would have stored our data in the columnar or comma separated form, but when we do the select statement part, so Hive itself actually present these values on terminal, right, with tab separated values. So that means every record, right, and in each record the column values will always be separated with a tab, and that the same thing, exact thing, will send to the like input Python script as a stream. So here what I have written, this should ideally get converted into this, right? I should remove, let me write it again, right? So once this one will be sent, so from this select statement, you can even see, right, this output is something which is clearly, right, tab is there, right, no comma and all. So that is something which will go exactly to this function. So first was USA, and then tab means simple 4 spaces, 1002, right, and then 4 spaces as a tab, then 100, which was quantity, right? This was the first one. Now India, this 1003, this 200, right? Now this first line will get stored in this line variable, correct? This whole line, USA, and on top of it we applied that \n \r, so our string is clean now, 100. After that, from this script, what we are doing, we are applying a split, right, split function, and split by the delimiter \tab. So whatever this line is a string basically, and this part actually presents the tab. So dot split method will get applied, and this will actually break this whole string into 3 parts. First part will be USA, second part will be string 1002, and third part will be string 100, because in the input stream everything we received as a string and we haven't done any typecasting as of now. And then you can see I have written on the left hand side, I have written values in such a way, right? So how this will be done, this is the you can say way of writing things in Python. So country, order num, and quantity. So after this splitting, right, whatever column sequence you have written on the left hand side, values from this part will get assigned to these things in that sequence. That means in country we will have a string USA. In order number we will have a string 1002. In the quantity we will have a string 100, right? So now we have splitted our input and we have stored it in individual columns. Now easily I can do the manipulation. So country is in string type, I don't need to do a typecasting, this is fine. Order number is in string type, right? So I can do this, you can say typecasting for this one, because in the input table its type was integer, so I'm following the same thing here. So order number, and then quantity here is, it's still in the string part and we want to do the manipulation on top of it. I need to convert it into the integer. Now everything has been converted, and after that if I do this quantity into 1000, right, I should get my result. So now this result has been prepared means individual column has been manipulated and whatever it is. Now, right, in our final select statement, I wanted country to be present there. I wanted order number to be present there. And I wanted this derived value should also be printed there, right? And since as I stream, you received this thing as a stream, you received this thing as a Python script where everything was string and it was separated by this tab. So same thing now during, or you can say while generating the output, this Python script will follow the same thing. It will convert everything as a string and will attach those individual values with the help of tab, means tab will work as their separator, and the whole string, or you can say the modified string, will get printed, and separately it will be taken care by the select statement. That will I will show you. So this part has been added, like our script has been added here. So what I wanted to do, I wanted to do these three things basically. First thing, I wanted to pass this, you can say, let me write it in much cleaner way so that you can see how it is being written. So select transform first country, comma, another value we wanted to pass order num, comma, third value we wanted to pass was basically this thing, quantity ordered, right? And after that, using Python, and our script name is .py, as now focus at this part, country string and order number integer, comma, multiplied quantity as integer, right? Using from this data set limit 10. Let's execute it and hope for the right output. Cool. So we can see our nice and very clean output on the terminal. Cool. So now in the first part, right, I explained that how, right, you will accept multiple columns as an input and everything needs to be taken care in the script in the same sequence, right? If you will mess up with the sequence, right, passing those column sequence in the transform, right, then things will not match according to your Python script because you have taken care it in that way. Now the thing which I wanted to explain, and somebody asked me that why you were publishing it as a string. So I think now you got the idea that how it will be done, and I will explain and seek your attention on this part to explain this part in the Python, right? So far here, right, on these statements we did our manipulation. Now the way we were receiving the stream, in the similar fashion we need to publish it, the stream, to the Hive engine so that it can read it properly. So that is why what I am doing, this is a normal way of writing things in Python again. So let's say what you had? You had a list of strings, right? List of string. Let's say hello, another hi, and another was bye. And you want to print it over the terminal, and you want these individual strings to be separated by hyphen when you publish it over the terminal. So how this can be done in Python? Very simple. So first, just in the single quotes or double quotes, use your separator. What you want to use here, I want to use hyphen and then dot join function. Means dot basically is a method. After the dot, I am just calling this method part. So join. This is not a like SQL join, all those things. It is a simple concatenation kind of join in Python, right? And this ARR str list. So how we will get our output over the terminal? Hello, hi, and bye. Correct. So same thing we are trying to do here. Here we prepared a list. In the list, first I written the country, comma, I converted order number into a string, right? Because here we converted it into the integer. So even if we wouldn't have written this part, right? Because then this one is not needed, because here our order num is already in the string, and that's what we want to publish it in our output, because we don't want to do any manipulation here. And then str quantity. So we have prepared that simple list which I was explaining here, this type of list. And after doing that, what I'm trying to do, I'm trying to just concat these things with the help of tab. Because here what was happening, if you look at this one again, I'm saying the stream which Hive was sending to us, there everything was separated as a tab. So similarly, we need to publish the output to the Hive engine separated by the tab. Now once the output is getting published to the Hive engine, so now here in this as statement, you can see, right, that stream, right, which is the modified one, right? Let's say if I pick this example, this was our output, right? Let's see how this was prepared by this Hive or Python script. So our multi-call UDF, right, dot py, it generated this output, right? Output, which was USA, then tab separation 10107, and then tab generation 30,000, right? So this is the output generated by our Hive. So now after this using statement, what I have written a sequence of columns and their respective data type, right? And this is the column, right? It is not mandatory that it should be equals to the input column, because here these are the derived columns. So it is up to you if you want to give a different name to it, right? That is why our multiplied quantity, right? We can see these three output numbers, output columns. So here now this output will be treated by the Hive engine, and in this part, right after this using, I have written country as a string. So whatever first value Hive engine will see for this tab, right? This is the first tab and this is the second tab. So this first one will be assigned to the country, and second one will be assigned to the order number, and we have kept its data type integer. So Hive will take care of it and will convert it into the integer. Same with the multiplied quantity. Cool. So that's what we had for the UDF part. Now you have all the idea how to work with single columns, how to work with multiple columns, how to do the splitting, manipulation, publishing it to the terminal, and to convert them in the respective data types, right? So now we will be taking a break, and here meanwhile I will quickly paste this script in the GitHub, and you can fetch it from there and execute it. So we have a break for next 5-6 minutes. Hey guys, so we are back again, and now we will be talking about the bucketing part, right? Which is again the super most important thing in the Hive. So let me share my screen again, and let me walk you through with this part, that how bucketing works and how it is needed. Let me know if my screen is visible. It is visible. Okay, awesome. Cool. So now let's focus on the another part, bucketing, right? So two things, right? At least from the Hive perspective, and your day-to-day activities with the Hive and your interviews as well. Very, very, very important. Similarly, bucketing. Very, very, very important, right? So last time we talked about the partitioning part, right? So partitioning basically another way to optimize the things in the Hive. So whenever we had the idea that okay, there are few columns in our table which are less unique, so and on those columns time to time we will be using it to apply our where clauses, group by clauses, and these kind of aggregations. So it's better to store our data in Hive table in the partition way. There were two ways: static partition and dynamic partitioning, right? So I hope everything is clear, because last time I explained it in depth with proper examples, single level partitioning, multi-level partitioning, right? So those partitions were basically, you can say, a way of storing data in Hive in the partition manner based on the some less unique values, so that we can optimize or we can avoid the full table scan whenever is required, right? While performing the heavy analytical queries. That was another way, right? Now coming to this bucketing part, right? So bucketing is actually something which you can say first purpose of having the bucketing part, the main intention to include it basically to optimize the join operations, right? To optimize the join operations in the Hive, right? So to optimize join operation. Second, less data shuffling over the network, right? So that was the main intention to that was the main intention to include bucketing and to come up with this bucketing kind of concept. So one common question you will see in the interviews, right? Obviously, the interviewer will directly ask, okay, what is partitioning and all those concepts, right? Which we discussed in the last class. Same with the bucketing as well. And sometimes people get really confused what is partitioning and bucketing, because both looks quite similar, but definitely there is a difference, right? And bucketing here, how it is going to actually happen, you can say basically why it is very much important. And from the interview perspective, the confusing question you can get, like when and how to use the bucketing basically. And sometimes people say, okay, bucketing can only be used with the partitioning, right? And sometimes people say, okay, partitioning can only be used with the bucketing. So both are individual, right? This is also individual, this is also individual. Both are not dependent on each other. Partitioning can be done separately, bucketing can be done separately, both can be done together, right? So just have this thing very, very clear with you, that it is not like that bucketing is completely dependent on partitioning. Both are independent and can be used together. So bucketing part, so in partitioning, right, what we saw, we will have a like column and less unique values. Simply, let's say, again, we'll take an example. We have, let's say, USA, right, and India, Russia, right, these countries. So there what we did, we created actually three partition, right? If you remember in yesterday's last class, right? So this was first partition, this was another partition on the country column, and its distinct value was India, and this was another, last one was the country, which is Russia, right? So this was partition. So how it was happening means we were explicitly loading data into these partition, right? In the static partition, let's say we had a source file which was containing only data for the USA. We had a source table which, let's say, there was a huge amount of data, and from that table we wanted to dump, or we wanted to pull the data only for USA and have it stored in this partition. So explicit load, right, was there. We were doing explicit load in partitioning, right? So the idea is basically of bucketing, or the simple definition of bucketing, to create a small chunks of data, or you can say to create small buckets. Sometimes it is known as clusters, not that Hadoop cluster and all, mini like clusterized thing. Whenever like things which looks exactly same, if you put it together, you call it like, okay, we have clustered it. And same goes with the bucket, right? So this is the idea of having the bucket, and the bucketing is something which will help in the most costliest operation, which is the join operation. Let's say the inner join, left join, outer join, right? All these are the join operation, because there more than one data set will get involved together, and lots of data shuffling will be happening here and there over the network. So in order to optimize it, we had this bucketing. Now I will explain this bucketing part, how it eventually works, right? So let's say you created three buckets, right? Three buckets for the balls, let's say, right? Let's say this bucket is only for red balls, this one for the black, and this one for the blue balls, correct? Now what will happen, let's say you had one large tub, right, box, where you have, let's say, multiple balls, right? And the color of the balls here can be red, black, blue, and they are mixed together, correct? Now mixed together, and obviously somebody would have given you a task that, hey, just from this box, let's create multiple buckets and store these similar kind of, you can say, balls together, right? And another thing to notice here, size of balls can be different. right? Size of balls can be different, but their colors will be three most of the time. Like only three color balls are only available in this box: red, black, and blue. But the size of balls can be different, right? So now you are doing this. Let's say you are here and you are doing this task, right? So what will happen? You visually you can see these things, right? Visually you can see, okay, in this box, let's pick one ball, and if it is red, it is black or blue, put it in this respective box, right? So here you are working, right, as a deciding factor. Deciding factor. So like you are the deciding factor who are deciding the things that, okay, this particular ball should go in which particular bucket, right? So after doing these things intelligently, you will place all the red balls here of different sizes, black balls here of different sizes, and blue balls are here in the different sizes. Now these individual boxes can be you can say used respectively in order to their respective manipulations, right? So same concept works in this bucketing part of Hive as well, right? So in the bucketing part, what will happen, as I said, we will try to create, or we will try to store our data in very, very smaller, or like say, we will just try to create multiple buckets in our Hive table so that respective data can get stored in, you can say, multiple buckets, right? So here again, I will take a, let's say, name, salary, right? How this bucketing is done. So let's say there is a name ABC, his salary is 1000, right? And his name is KLMN and 2000, right? And here is OP 3000, correct? So these are the three folks here. Now what happened in your Hive, right? And I will talk all the syntaxes, how to use the syntax to create the buckets and all. So don't worry about that one, correct? So let's say in your Hive, what you did, you created basically, you created three buckets, right? This is bucket 1, this is bucket 2, and this is bucket 3, correct? This is your bucket 1, this is your bucket 2, this is your bucket 3, and its ID is 0, its ID is 1, its ID is 2. Here in the middle, right, there is one hash function, and this hash function is nothing, basically this function is equivalent to you here, because here you were deciding in which bucket this particular ball will go to. So here this hash function, so in order to create a bucketing, right, bucketing, or basically to clusterizing the things, you should be picking one particular column, and you will choose that column to distribute your data in such a way so that it can be converted into smaller chunks or smaller buckets, right? So here what we will be doing in this hash function, we will be passing this name column and name value, you can say, correct? Now the definition of my hash function is pretty simple. Just calculate the length, right? Just calculate the length of this, whatever name value will come to, right? And take a mod by number of buckets I have created. So let's say 3, correct? So whatever value or whatever remainder will get generated, that will be equivalent to the bucket ID. This is how simple hashing things, right, are working here. So first, let's say this record, right, we wanted to store in our Hive table. So Hive will try to figure out, okay, I have created buckets, multiple buckets inside me. So in which bucket I should put this particular record, correct? So how this is going to happen here, this ABC value will be passed to this hash function Now quickly let me know in the chat box in which bucket this record will go to where name is equivalent to ABC. Great, multiple correct answers. So it will go to bucket 0, right? Why bucket 0? Because length ABC, right? ABC mod 2, mod 3. So it will be 3 mod 3, and mod of 3 will be what? Remainder we can say 0, correct? And as I said, whatever will be the remainder, that will be treated as a bucket ID. So that means the particular record where name is equals to ABC, the whole record will go to this bucket ABC. Now quickly tell me where this record will go to, KLMN1, where this complete record, in which bucket it will get stored? It will get stored in this bucket B2 because its ID is 1. And if I take a length of KLMN, right? So what it will be? It will be 4, something like this, and remainder will be 1, correct? So KLMN will go to B2. Now let me know about the third one, right? Third one, OP, where it will go to? Bucket B3, because length OP, it is equivalent to 2, like taking a mod of 2 by 3, and obviously, right, it is not divisible or something like that, so it will be 2 itself, the remainder. That means this OP record is going to be in this one. So here you have got the entire concept, right? How this bucketing is going to happen, right? How this bucketing is going to happen in our Hive. And now let me add more records to it, right? Let's say KKG, Sikandar Khalo, right? So 4,000, and after KKG, right, let's add, right, PTPO, something like that, 1,000, right? And again XY, right, 5,000. Right? So now we have added these 3 records, KKG, PTPO, XY, correct? So here we are doing a bucketing. That means this bucket will get applied, or this whole concept of bucketing will get applied on this complete Hive table, right? So now one thing we need to understand, that is why in this problem statement, what I added, size of balls can be different, but one thing will be unique among those balls, right? If let's say 3 balls, different sizes, one thing can be common among them, their color will be red. That means this output value is something which is common. So similarly, there can be multiple records which might be generating same remainder values, and in this case, all those kind of records will be stored in the same bucket. So this is the whole idea of our entire bucketing concept. So now if I look at this record KKG, so similarly it will generate the remainder 0. So this record, where it will go to? It will go to bucket B1, right, KKG. And if I go for PTPO, it will go to this bucket 2, PTPO. And same for XY, it will go to bucket 3. So now you can understand the hash value of many input values can be same. So based on that one, it will be decided, okay, in which bucket it will go to. So now you can see this was our whole data set, and now we have divided our whole data set into the tiny buckets. And since I explained all this hashing kind of functions, hope you are able to understand it. It is not equivalent to partitioning. Get it? Or right, you have any confusion that no, this is looks like partitioning? Because here you can see I haven't used any concept of partitioning. It is very different from partitioning. I will explain it why bucketing is needed, right? You will definitely get the idea why bucketing is needed. In the beginning, as I said, I written all like these two things to create small chunks of data. This one to optimize join operations and less data shuffling over the network. You will get that idea. I will definitely show you the practical. Don't worry. See, I am getting questions here, right? Why I am not doing bucketing on, let's say, salary, why I'm doing it on a name. So again, the way I explained it for the partitioning, how you were deciding in the partitioning which column you will use. Most frequently used column, right? So in the bucketing, see, bucketing, how you need to decide. So again, I will refer or go back to the join functions, right? So join will be like inner join, left join, right join, all these things of joins will be here. And there will be two data sets, D1 and D2. Let's say this data set D1 had column ID and this D2 data set had column ID, and these two data sets will frequently get joined together with the help of these two ID columns. Now tell me which column should I pick for dataset D1 and dataset D2 to create the bucketing? ID column, right? So since in the beginning I mentioned that bucketing is something, right, which will help us to avoid the shuffling over the network, because shuffling will come into the picture when mostly we will be doing with the join operations. And another thing was, right, it will help us to optimize the joins as well, right? Next few concepts which I will tell you, right, in Hive, that will completely blow your mind. If you, anyone who haven't looked Hive as of now or haven't worked on Hive, right, your programming logical concepts will also come into the picture. So now this point, right, you are clear that when, like for the bucketing part, which particular, hey Girish, please don't spam in the chat box, right? So here what you need to understand is basically we have different data sets. So what could be the reason or what is the suitable column which we need to use in order to use for the bucketing or to create the smaller buckets and the chunks, right? So since this is something which was this concept of bucketing basically you can say was derived or implemented to optimize the joins, and that is why whatever columns we will be using frequently in the join operation, those needs to be right, added in the bucketing. So Saurabh, you are asking, while joining two tables, don't we use usually joins on primary keys? So first of all, in Hive, we don't have any concept of primary keys, right? This one I already explained in the previous classes. And here, yes, the column which is like going to be used regularly, right? That is something you need to sometimes, right, use for the bucketing part. Correct? Awesome. So now this part is explained. And one thing I want to clarify here, in the partitioning, right? Partitioning, we were able to do the multi-level partitioning as well. Correct? So in partitioning, we were able to do the multi-level partitioning, but in with respect to the bucketing, it can be only applied on one single column, right? So that is why always this is the best practice, right? This is the best practice. Mostly the way we work in the production level application, we try to bucket our data with respect to the ID columns, because most of the time we will be using these ID columns to join the join our data. And also one thing we need to make sure as well, that this is something, right, this column or the column which needs to be used for the join, it is different from the partitioning. Different, not, I'm not saying that different, like whatever you have used in the partitioning you cannot use, but in the partitioning we were using that column where less unique values were there. Here our idea will be choose that column first, like prefer mostly you are using in the joins, and here values should be, you can say, more distinctive, because what will happen, right, and this is one of the very common problem in this big data processing, right? This is something you need to understand, and this can be asked anytime, right, with you in the interview, right? So if I use my same hash function and we had these three buckets, let me know where all these four records will go to. B3, right? So all those four records will directly go to in this one, and these buckets will be empty. And this will add a great disadvantage, right, of creating the buckets, because this will not help us to optimize our join operation, because this phenomena is known as data skewness. Everywhere this phenomena is very common. We will again see this part in the Spark, but this phenomena is very common, data skewness. If the way your data is getting partitioned, or the way your data is getting splitted, or the way your data is getting bucketized, right, if the maximum number of records are going at one partition, one bucket, or all those things, this is the data skewness. Means you are just putting an extra load on one particular bucket, and it is not giving us, or it will not give us any kind of optimizations, right? So Jagdish, for your question, right, this is smartly handled by the Hive, right? The hash function which I explained, it was a dummy operation to help you understand how hashing actually works, but Hive engine is itself very smart. If you are giving a column where most of the time you can see unique values, Hive will automatically will try to implement that kind of hashing algorithm which can distribute data in the even manner, right? Not adding that much skewness. Right? So for the partitioning, I can again write, for partitioning, pick less unique column. For bucketing, yes, Hemant, you are correct. Hashing is something which will be done on the other factors, right? Length was just an example. Again, don't treat it like a Hive has implemented it, the length based function in the backend. It is completely different, a complex hashing algorithm, which is generating or trying to divide the output in such a way. For bucketing, pick a column which is unique. Preferred join key or ID column. Cool. So now let's quickly come back to our practical part, and I will show you that how this is actually done. Correct. So first, I will prepare our data set for our use case. So vim users dot CSV. Right, values are say 1, comma Amit, comma 100, comma DNA, $200, Sumit, ID 2, DNA 300, cool. So this is our one data set. This is basically our users data, and now we'll just create simple locations data, and locations data will basically represents which user is living in which location or the state of India, right? So 1, comma UP, 2, comma Bihar, comma 3, MP, 4, Andhra Pradesh, 5th, Maharashtra, 6th, Goa, and 7th, Jharkhand. Right, so this is as simple as that. Now we will quickly go to our Hive and we'll create first 2 plain tables, and in that table we will load this data, and then we will create our bucketized table, and from those plain tables we will load data into the buckets, or you can say bucketized Hive table, right? So let's quickly first let me move this data to our temp location, users /pmp Hive class is there, cp locations temp Hive class, it is there, then start Hive, use Hive class 4, and first set hive dot cli dot print dot header equals to true. And let's start creating our table. First table is create table users, and first column is our ID column, which is of integer type. Second column is name column, which is again integer type. Sorry, not, it is string. Third column is salary, again of integer type. Right now, unit, in which unit they are working, is of a string. And now row format delimited. Right, row format delimited, and fields terminated by comma. Right, our table is created. Let's create another table. First, let's try to load into this one, and then we'll create another one. So load data local input path will be our file / tmp hive class, and this is our data users.csv into table users. Let's try to query it. Select a star from users. We can see the data is there. Now let's quickly create our locations table and load the data there as well. Create table locations, and in that one we have ID, which is again simply employee ID, you can say, and then location, basically a string, and then row format delimited, and fields terminated, fields terminated by comma. Table has been created. Let's load data into this table as well. Locations, CSV, and let's run it. So select star from locations. Cool. So both are our plain tables. Plain tables have been created. Now I'm going to write the syntax, right? So syntax for the bucketing table, right? How to create a table which will use some column to create the buckets, right? And how to load the data into it. So for that one, simple, the table name will be create table bucketized table. So I'm adding this one. You can name it whatever you want. So bucket users, right? And here first column will be ID, and it will be integer, name, it will be string, and then we had the salary, and it will be string, and then we had the unit, it will be string, right? And another keyword which you need to focus, and now here at this moment you need to tell me a difference as well, right? When anybody sees a difference, tell me how it is different, this syntax different from the partitioning. So for that one, the keyword, in order to create a bucketing table, we will use this clustered by keyword. So clustered means those mini batches, or the bucketed, you can say. So clustered by ID, right? Clustered by ID. So can you quickly, anybody remembers or anybody able to capture the difference from the syntax of except this clustered by keyword? Anyone? All right, no problem. So when we were using the partitioning things, right? So there what happened, whatever column we were using for the partitioning, that was not the part of the create table, right? These columns, but here we can use it, the column, because here we are not going to create a partition. It will be a bucketing part, correct? Like buckets will be created. So this is basically to help the Hive that, okay, which column will be used. So clustered by ID means for bucketing, I'm going to use the ID column. And then there is one more thing which will be added sorted by, and I will tell you what is the reason behind it. This is again something to optimize our joint part, but I will explain how this sorting and bucketing will work together and how it looks like, right? Sorted by the ID column. And apart from that ID, any other column can be used as well in this sorted by. You can even use the unit name. You can use the salary as well for the sorting, and more than one column can be used for the sorting part as well, right? But here I'm simply using the let's say ID column. Let's say there are multiple IDs, which multiple records which are having the IDs, and those IDs generated the same value for the bucket, so they will be in a same bucket. So within that bucket they should get organized in the ascending order of the IDs. So that is the whole purpose of adding the sorted by, right? And after that, how many buckets we want to create? Into 2 buckets, right? So that is how our bucketed table definition has been created. Now quickly we will create a bucket for the location, or you can say a bucketized table for the locations. So here ID int, and after that location string clustered by ID sorted by ID into 2 buckets, right? This is also created. Now, before doing the load part and all, let me quickly explain that how this sorted by is actually working, right? So let me quickly explain this part as well. Nothing complex, although very simple to understand, right? So let's say name, salary, correct? So here, so other columns can be used for the sorting part, but there will be one great advantage of even having the same ID column in the sorted by. I will tell you where it will help, but generally I'll give you the idea that how this sorting is actually working in the bucket part as well. So again, let's say the name ABC was there, right? And let's say KLMN and right, KLMN OP XYZ MNC TP, right? So ABC, let's say 1000, right? And this is, let's say 500. This is, let's say 2000. Let's say this is 1000. And this is, let's say 800. This is, let's say 200, right? So this is how our buckets were created, correct? So clustering, we decided that it will happen on the name. So here, first, what record might be present here? ABC 1000, and then XYZ 500. Correct. Similarly, KLMN 2000, and then MNCC 1000. Similarly, OP 800, and after that TP 200. So let's say in our clustered by syntax, clustered by name, and if I did it sorted by salary, ascending, right? By default, it is ascending. So the way these records in one single bucket will be arranged, they will be arranged on the ascending order of this salary part, right? So ultimately, how it will look like in the bucket, it will look like something this: XYZ 500, then ABC 1000, right? Similarly, this one, similarly, this one. So this is the whole purpose, or basically, this is how these records will look into the buckets. But the primary advantage of using the IDs in the sorted by column, you will see when I will be explaining the join part after this bucketing part, right? So only just two things are remaining to show in the bucketing. So in order to work with the bucketing, we need to set one property in Hive, right? Hive shell. Once this property is set, after that bucketing will be enforced. So that property is Hive enforce dot. If that property is not set, then Hive will not even know that I need to do the bucketing on top of this particular table. So that is how we need to enable it. Set hive.enforce.bucketing equals to true. This property is set. Now one by one, from the plain tables, we will load data into our bucketized tables. So for that one, insert override table bucket users, you can say, select star from main users table, right? So let it get loaded, and then I will go to the like the Hive warehouse, eventually the HDFS path, and I will show you what will be inserted there, or how files will be created there after this one, once data is loaded in these two tables. Right, so this is done. Let's load the data in the locations table as well, and then let's check it out in the warehouse HDFS location. Insert override table bucket locations. Now here I will quit it. And we'll go to the HDFS path. So Hadoop fs-ls /user /hive/ right. So our warehouse will be there. Okay. Data has been loaded in the locations one as well. First, quickly, let's do a select star in these bucket tables as well, just to verify. Select star from the bucket locations, let's say, right? So yes, in the bucket location, bucketized table also, our data has been loaded. Okay, let's quickly check it out in the HDFS path, how this is stored or looks like there. So warehouse slash hive class 4 star. So this bucket table we created, right? So let's do a ls for this one. Cool. So what you can see here, and can you tell me why it happened, and how many things you can see here, and what was the reason? Now you understand everything. Two buckets. So in the directory, right, you can see simply two simple partitions got created, right? Or here you can say these are the buckets itself, and in these buckets our data is eventually got stored based on the logic whatever was being taken care by the Hive. So now again, please don't get confused. Bucketing is not going to help you with the whereby queries and all these things, because for that one, first you should have the partitioning. Partitioning is something which will help you to avoid unnecessary data scan. Bucketing is not going to help you in any of those things. Bucketing is definitely super helpful, right? To definitely first create multi-partition data set. Another thing is this is pretty much helpful for our join operations, and that is something which I will show you next, and you will get all the idea like what is the purpose of having the simple joins, right? Or what is the purpose of having the bucketing and how bucketing helps in optimizing the join operations. So this part is clear. I will quickly just paste all these scripts in the GitHub repository. So hope you have got the clear idea about the bucketing, partitioning, how the syntax is being written and how it can be implemented on the Hive. And let me just paste this thing. For this one, let me, okay. Use below Hive statements. Use below Hive statements for bucketing. Let me paste the whole script for creating the tables. Okay, this is our first table, right? This is our second table. All right. And then we will create our bucketized tables. And then let's create this another bucketized table and then write the load command. Load command is done. Buckets, load data into buckets one by one. So first we loaded data in the users table, And then we loaded data in the locations table. Locations table, where are you? Here is the locations table. Okay. And then I need to upload the sample data as well. So this one is committed. So where is the sample data? Okay, ls when users, just copy this data into the GitHub, add a new file, users.csv. Here it is, committed. Then locations.csv, and create a new file for it. New file, locations.csv, done, and commit. All right, so again, let me share the GitHub repo link. So the script and the data set has been loaded. And yes, let me add this one. Thanks for reminding it to me. Let me add that command as well, the enforcing for the bucketized part before the load operation. All right. So this is also done and committed. Cool. So this is committed. And now let me send it. Cool. Let's take a 5 minutes of break and then we will start with our last topic of Hive, which is joins. All right, guys. So I'm back. My screen is visible, right? Cool. So can you see one thing in the chat box? Sorry, in this screen, you can see, right, how our data is divided easily. Visible, right? In those two, we created those two buckets and this is divided. So that is how things will time to time depend on the number of buckets you are creating and how data is putting it into the buckets based on the column you have used. So I think now it should be pretty straight and clear that the use of bucketing you will know more when I will explain more about the join, but at least how it works in the backend. So your question is how we can conclude how many buckets we need, right? So buckets for that part, right? You need to depend on your data size as well, correct? So you need to do few statistics first. You need to run or you need to pull some statistics first from your data, that how many distinct values, let's say for that ID column mostly you are having, and the number of or the amount of data or the number of records you are going to handle, right? So that is how you need to decide how many we can basically how many buckets eventually it should be there, right? Is synonym of bucket is clustering in other databases? Yes, correct. That is why this one is basically named this one is basically named as the clustering as well. Like when we write the syntax clustered by, so that is definitely works like a clustering in the databases. Yes, Hive take care of this internal hashing functions. Awesome, cool. Let's move on to the joins part. Let me share my screen is shared. Okay. All right, new discussion, new page, completely blank. Okay, optimize joins. Optimize joins. Optimize joins. Cool. So optimize joins. Before that, there might be a couple of folks who might be thinking that what is this join part, how it works, and what is this blah blah stuff. So for anyone who don't know about these join operation and these things, don't worry, right? This is my responsibility to teach you all these things in depth when we will jump onto the SQL part, right? So SQL, there I will take care of all those things in depth, but I will quickly give you the rough idea how these joins work, because very logical to understand. Again, not a rocket science, but from the implementation and other different type of joins, all these things, right? I will cover it in the SQL part, correct? So the quick level, or you can say quick overview, would be, we have basically, you can say on inner joins. So right now, right, I will basically talk about the general join operation, will give you the idea, but majorly my focus will be to talk about optimized joins in the Hive. I am not deeping dive into the joins of simple, you can say the SQL and all those things, but still I'm just giving the idea that in the SQL and Hive, these things will be pretty much common. So the majorly there are 4 type of joins, like inner join, right, left join, right join, fourth is full outer join. Correct. So I'll quickly explain it with an example. So we'll take a same example, right? Let's say we have ID column, right? And this name, and this is our user table, right? And this is our location table. Correct. Here we have again ID and location. Correct. So ID1, Shashank. ID2. Now let me know, where does Shashank live? I'm just keeping it blank. Gurgaon is my workplace. Shashank, Rahul, and Amit. Dubai. Wow. Nice. Yeah, so I live in Lucknow. My hometown is Lucknow. So Amit, and let's say fourth, some ID, and Goa. Awesome, cool. So first type is the inner join. So inner, mostly, right, when we join two data sets, join will happen on some, right, join keys, right? So first is inner join. So we have two tables, right? One is the user and the location, and we can see this ID column is something which we will be using for the joins, right? Because this is the data we have. So the meaning of inner join is basically complete match. If complete match only in the result, right? So for any ID, right, if we have, let's say, written our join let's say users, in our join condition is users ID should be equals to the locations dot ID, right? So we can see this one will get matched with this one. So in the final output, how our output will look like? Our output will look like 1 Shashank, right? 1 comma Lucknow, correct? And second one for this one, right? 2 is matching with each other. So 2 Rahul, 2 MP, right? Now here for this record, right? ID3, there is no as such record in this locations table, right? So definitely we cannot join it. So this record will not be a part of output. Only these two record will be our part of the final output, correct? So this is how we are doing it. And similarly, let's say even on this table, we can see 4 is an ID, but there is no record on the left hand side for this one. So this is also getting discarded, right? The whole record. So this is how the inner join works. Complete match only in the result. In the left join, what happens? Left side data will be populated if there is no match, correct? So in the left join, how this is going to actually work? So for this one, right, this is our here in this join operation, left join, I am keeping users table on the left hand side, right? So whatever will be on the left hand side, we need to take the decisions accordingly, and locations ID, correct? So here, if you see, right, this one, for this one, we have a match, everything will be sorted, means we will get the correct output. For this one, we have a match, everything is sorted, we will get the output. But for this one, there is no match on the right hand side table, but still we will include this record in the final result. But these value will be populated. But for this record, whatever will be the corresponding column from the right hand side table, those will be populated as null, right? So what will be our final output? 1 comma Shashank comma LKO, 2 comma Rahul, I'll tell you an interesting story about me and Rahul. So many coincidences, right? MP and 3 Amit, right? This will be null. Right hand side part will be null because for this record, right, there is no match for the right hand side one, correct? So that is something. This is how our left join works. Now you can easily get the idea how right join will be working, right? Right join, the vice versa of left will be known as the right join. So right side data will be populated if there is no match. So here again, I'm keeping users dot id locations dot id. So how it is going to be? For this one we have a match. For this one we have a match. And since this is a right join, so left hand side data will be completely null for that record which is present in the right hand side, and for this one there is no match on the left hand side. So how this final output is gonna be look like? 1 Shashank 1 comma LKO 2 comma Rahul 2 comma MP, and left hand side will be null because for right hand side data there is no match. So 4 and Goa. Now one quick question here, guys. For this left hand side, at max how many records we will be getting in our final output? This is a just general question based on the observation, right? How many records we will be getting in the, I'm not asking for this respect. Let's say, let me give you a simple problem statement, right? Let's say in the left hand side table, right, there were 100 records, and in the right hand side table, right, there were 200 records, and I am saying every ID column is unique, right? It is not duplicated. So if I'm doing a left join, so at max, how many records we will be getting in the final output? At max 100 records, right? Yes, because see, this is the left join. So left join, what we are trying to do, right? 100 records means doesn't matter if there we see a match or mismatch. All those 100 records will be present in the final output because we are performing the right hand side join. Sorry, we are performing the left join, correct? Now just reverse the problem statement. If we are doing the right join, then how many records will be there in the output? And I'm asking at max because that is the problem which will justify it. 200. Yes, you got it right. So you got the fundamentals of the like joins and how simple basics of it work, but definitely you will see all those things in depth, right, when we will be into the SQL part. So left, right, this thing is done, and the fourth one is the full outer. Full outer, very simple, very simple. It is simple. Inner plus left plus right. Simple. Just sum all those things together, you will get the full outer join. Right? So how this full outer will work? So 1 comma Shashank 1 comma LKO 2 comma Rahul 2 comma MP, and for the left hand side there was one record 3 comma Amit, but for this one there is no match on the right hand side table. It will be null comma null. There was one record in the right hand side table 4 comma Goa. For that one there was no match on the left hand side, so it will be populated as a null null. So you can see this was the output we were getting from the inner join, and combine this one we were getting from the left join, and this whole together we can get including the right join as well. So that is how the full outer will be working. Cool. Now I am going to move on to our Hive optimized join, right? So in Hive, right, majorly we will be talking about Hive optimized joins, and I will explain it one by one. Cool. So for this one, how it is going to be? First will be our reduce side join. Just take a note of it. Second will be our map side join. Correct. Third is our bucket map join. Now you can see, right, there is a specific join itself, which is like for the name of bucket itself. So you can now see the importance why it was even being created. So bucket map join. Third will be sorted merge bucket map join, or known as SMBM, right? So these will be the 4 joins, right? I will explain it one by one as well, and I will just execute it as well for you so that you can get the better idea, and I will explain all the internals of it, right? How at least the bucket side, the map side join side, those are very important to understand. So in this reduce side join, what do you think? What's its name suggests, right? What will happen in the reduce side join? What do you think based on this statement? Right. So again, guys, don't consider like these 4 type of joins with the typical joins of SQL, right? I'm just asking from the internals perspective that what do you think that if I have included a name reduce side join, so what would be happening here? Yes. So many of you have it answered it correctly, correct? So in the reduce side join, what will happen? The whole join will be happening on the reducer side, right? So in this case, I need to just take you back to that map reduce part again, correct? So there, if you remember, I explained when we do the map reduce processing, the block size, all those things, just refresh your memory one more time, right? So here we had that map task M1, M2, then M3, and then M4 and all those things, right? Then after that, something was happening in between here, right? And after that, things were going to different reducers, right? R1 and R2, and here all the aggregation related things were happening, right? So now in this reduce side join, as I said again, the main purpose to include the bucketing was to optimize this join part and to help the Hive with minimal data shuffling, because here, right, this is the normal, let's say, phenomena of the map reduce functioning, where mapper, whatever output it will generate, that will be written to the external disk, and from there the sorting, shuffling, combining, partitioning will be happening. But when we have these kind of operations like group bys, right, joins, So now you can even imagine, just ignore the distributed computing part, right? If you, let's say, don't have Hadoop, you don't have Hive or anything, in simple MySQL or simple SQL, right? You have everything at one place in your database. You will see that entire table is present at one single machine. So if you perform the join, you will be getting the correct output, correct? But in the distributed computation, right? So when you are performing the joins, let's say some data will be here, right? B1. So in the join operation, you will be using few keys. So for that keys, few records will be here, 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 right? And this is not only with one data set. Let's say you use data set D1, right, which is on the left side, and data set D2, which is on the right hand side. And since both are stored in the HDFS, their data will be stored on different blocks, correct? So in order to perform the complete and right join, so how it should happen, obviously whatever data needs to be joined together, whatever keys need to be joined together from both of the data sets, they should be present at one single place, or any sophisticated mechanism, so that those common keys from those two data sets, right, can be placed together at some place, so that the exact join can happen. If that is not doable and data is still in partitions and present over here and there on different data nodes, then we will be not able to get the right join output, right? So in the reducer side, it is very simple to understand. Let's say you have four right mapper task, and here data set for D1 as well and data set for D2 as well, same here, same here, same here. So obviously I should have one single reducer, right? I should have one single reducer, so that data for D1 D2, which was partitioned, right, which was partitioned and was distributed here and there, let's try to pull it in one single reducer, so that the join can happen. Now logically, just think logically, in which case I can apply this kind of reduced side join. Just think logically, very logical, basic common sense. Just stick with your fundamentals, that how we just create reducers and how distributed computation happens, how resource allocation happens, right? Cool. So I saw few right answers, right? But still, let's say folks are a little bit confused. But see, this reduced side join can be applied when both data sets are small, right? Both data set which you are using for the join D1 and D2. And I'll tell you why. Because as I said, just stick to your basics. So we have these many mapper tasks, right? But one single reducer. So one single reducer, where it will be running, it will be running at one machine only, correct? And one machine has its own capacity of RAM, let's say 32 GB RAM only, correct? And some CPU, right? Let's say 16 virtual cores, right? And network bandwidth. So by any chance, let's say your data sets, those are 100 GB big. Both D1 is 100 GB, D2 is 100 GB. So would you be able to process these two with the help of reduce side join, right? Is it possible? Right? Is it possible to just do the reduce side join with this many big or huge data sets? Absolutely not, because that reducer cannot do it. So that is why reduce side join can be done or should be preferred, right, when both data sets are quite small, very small, let's say simple dimension tables, and you just need to check out something on that one, right? Then in that case, this can be preferred. Cool. So first, let me quickly show the practical for that one, and then I will move on to the map side join. Correct. So everything is set on our side. So in order to do the map side join, right, we need to first set one property, because this property is by default will be set to true, right? So set hive dot auto dot convert dot join equals to false. So if this property will set to true, so Hive right, intelligently looks that okay, we need to perform some join operation and it should be optimized, right? Or map side joins and these kind of things it will try to apply. But forcefully I want to stop that property so that we can test out our reduce side join, right? So first we need to set this property, set hive.auto.convert.join equals to false, and then let's try to do the join operation, simple inner join operation on our users and locations tables, right? So select star from bucket users, and I will give a name to this alias as a u inner join bucket locations L on users.id equals to L.id, right? And simply just run it. So here you can see two mapper tasks got created, but what is happening? One reducer is there because this join is happening as a reduce side join. So every data or like everything is present at one single reducer. Got it? Practically. And here we can see our inner join data. Cool. Now let's get back to the second one. So ID, somebody asked, there was ID 8, where is that one, right? So I will show you, right? Let me share my GitHub repo link. Cool. Let me open this this users data. So users data, there was, yes, one user 8, right? And its name was Chandra, correct? Now let me go back to location, and that was very simple to understand. If in the inner join, if we didn't get any output, so do you think there would have been any match in the location table for the ID 8? What do you think? Why we didn't get that output? No match, right? And I can show you. So if we go to this locations table, as simple as to understand, 1 2 3 4 5 6 ID 8 is not there. That is why that join didn't happen. Cool. Now moving on to this map join, right? Again, very important to understand, and I will explain it. Right? Map side join, and sometimes, not sometimes, mostly it is known as broadcast join. Correct? So how this broadcast join actually works, let me explain it in that way, right? So let's say, right, we have two phases, right? Map part again, right? This map part, this map part, and this map part. And this is the reduce part and this reduce part, right? So M1, M2, M3. This is R1, R2, correct? So let's again take an example of our users data, right? So let's say for users data, right, records 1, Shashank, 2, Amit was getting processed by this mapper 1. Record 3, right? What was record 3? Users data. Yeah, record 3, Yadav 4. Record 3, Yadav. Right? 4 was Sunil. Let's say those were getting processed by this map M2. Correct? Now, Kranti and Mahur 5. Kranti 6. Mahur. Right? And let's say there was one more map task which was processing the last one, Chandra. Correct? So let's say this is how our map tasks were processing the output. Correct? Now, obviously, there was another data set which has to be joined with the whole location, with the whole, you can say, the user's data, right? So for that one, how it is going to happen? So this is our locations data. And let's assume, right, this user's data is somewhere like 100 GB. And this locations data is, let's say, simple 200 MB. Because see, locations data is somehow a dimension data which doesn't get changed very frequently. Location, let's say in India, right, we have different states. So whenever, let's say, some split happen, then new entry will be added, else like 28, 29 states will be there. Correct? And that data is very short and very small in size. So now here the join needs to be happen. And I said in the beginning, in the distributed computation world, if you want to join the data, that means that should be presented at one place, right? That should be presented at one place. In that case, you will be like able to join the data, right? So in this case, how it can be done, right? If we want to perform the map, if we want to perform the joins at the map side, obviously it will increase our processing part, because in that case, join is being done locally by each mapper and there will be no involvement of reducer. And since there is no involvement of reducer, right, mapper, right, this even data shuffling and all these things will not occur, because reducers even don't need it for any kind of computation and all, because the join has already happened on the map phase itself. So in this case, what will happen? This location table, right? This location table will be sent to each mapper task, right? Wherever, let's say, this mapper task is getting processed on data node D1, this one is processing on data node D2, this one is getting processed on data node D3, and this one is getting processed on data node D4. So this location table we had, right? What will happen? In the location table, the whole table, right? The entire copy of location table will be sent to each data node where this execution for M1, M2, M3 will be happening, right? So same copy of data, that means full data. Again, I'm saying full data, not the distributed or splitted one. Full data will be sent to each mapper task. Now, this data set can be joined effectively with this locations data, because locations data complete the full one. Correct? So now you got the idea that how map side is join is working. There is no involvement of reducer. The whole copy of locations data will be sent to the mapper task, so that every key is present there in order to get joined, right, together. And the constraint with the map side join is, right, one data set should be smaller enough to get fit in the memory, right? That is how we will be able to perform the map side join or reduce sorry, map side join or the broadcast join, if again data sets are very, very big in, let's say GBs, 50 GBs, 100 GBs, map side join cannot be applied. Got it? Fundamentals are clear? Cool. So map side is also clear. Now let me just run it practically, that what all properties we need to change in order to perform this map side join. So earlier what we did, we just turned off this, that convert dot join property for the false. Now simply we need to just enable that property, and that will be an indication for the Hive that I need to perform a map side join. So set hive.auto.convert.join equals to true, right? And now let's run this same join operation. Just a second, right? Let it get executed. So here you can see number of mappers 1, number of reducers 0. Correct. So here you can see there was no involvement of, you can say, reducers you see here. And simple thing, where this join happened on the mapper side itself. Now let's look at the another one. What is the next one? This is our bucket map join. Cool. So now, since we talked about, okay, in the reduce side join, data should be small. In the map side join, right? What we said in the map side join, one data set should be small, right? We allowed that constraint. But what is the situation, or what is the thing where, right, let's say both of our data sets are very, very big enough, right? In that case, how we can simply optimize our join part, right? How we can simply optimize our join operations. So again, this fundamental of bucketing will come into the picture. Correct. So now let me explain this one, that how it will be happening. Correct. So for that one, right, let's say this is our users table, right? This is our locations table, right? So in the users table, what we did, we created, let me erase it. I want to make it more cleaner for you guys to understand. Right? So this will be our one bucket. Cool. So this is, let's say, bucket B1, bucket B2, bucket B3. Here you need to assume, right, all those things which I said. Here, just assume we created 4 buckets, and this is the bucket B1. This is the bucket B2, correct? So in this one, let's say the way our buckets got created. So 1, Shashank, 2, Amit are here, 3, Yadav and Sunil, 4, Sunil, 5th, Kranti and Mahur, 7th, not 7th, 8th, Chandra. Right? And let's say in the locations table, we only created 2 buckets, right? So 1, yeah. So UP, 2, Bihar, right? 3, MP, 4, AP, 5th, let me write it in that way so that in the next part I can quickly show this amazing thing to you, right? Which is the sorted merge join. So let me quickly write it in that way. Bucket P1, right? So let's say 3, MP, 1, UP, 2, Bihar, 4, AP. Now bucket B2. Let's say 7, Goa, 5, Maharashtra, and 4th, not 4th, 6th, Jharkhand. Cool. So assume this is how it is going to look like. So users data, there what we did a clustered by on ID and into buckets 4, right? So this is how, let's say, our data got divided in different buckets for the ID column. Similarly, for the locations table, we did a clustered by on the ID column, and this is how our data got divided in the 2 buckets, because there we use the 2 buckets, correct? Now the challenge we had with the map side join and the reduce side join. So I'll refer the map side join because that is important to discuss. So in map side join, we had to send the entire data set. Which one was the smaller? We had to send that entire data set to that data node where this mapping was, like the map task was actually getting executed, so that the complete join can happen, correct? So see, here we have used this ID column for our bucketing. Here we have use same ID column for our bucketing. The only difference is that here we have increased the number of buckets and here less number of buckets. But again, the ID is something, the column is something which is common. That means the splitting which has been done, that is that has been done in the smart way by the Hive itself, so that these smaller buckets can be used in the join operation, right? Since it is the bucket map join. So again, what will happen, right? This is our, let's say, map task 1, right? And this is our, you can say simply map task 2. Let's say only 2 mapper tasks were needed, and the data we have in the bucket B1 and bucket B2, that is getting processed on this mapper 1. And the data, right, for the, let's say I will be writing u.b1, that means users bucket, correct, and users bucket B3 data and users bucket B4 data is getting processed on this mapper task, correct. Now we had another data set, correct. So now among these 2 buckets, let me know in the chat box which bucket I need to send to this M1 and which bucket I need to send to this M2 task. So somebody said both, correct. So this is wrong, right? That is not how we are supposed to use the bucketing, right? So the idea of bucket was basically to create buckets in such a way so that we are not supposed to send this complete data, because that was we were doing in the map side join. We had to send this whole data, and let's say this is very, very big enough, right? So how it will be done, right? That is something which is not right you can do, because data set is very small. So now just imagine these 2 buckets, right? These 2 buckets data is actually present on this mapper task M1, and what all IDs are here? 1, 2, 3, 4. So if I want to perform a join operation, right, if I want to perform a join operation, so I need to look at this one, 1, 2, 3, 4, and I just need the data for ID 1, 2, 3, 4 from my locations table, correct. Are you with me till this point? I only need this data 1, 2, 3, 4 in mapper task M1 from the right hand side table. I don't need any other irrelevant data, because for those the data, the values of the IDs are not present here. Since only 1, 2, 3, 4 are present, so it makes more sense if I can only send this bucket data to this mapper task, right? That means the location bucket 1, I only need to send this mapper task, and location B2 bucket, I will send it to this one. So in that case, since these buckets are very small in size, so ultimately we have leveraged the map side join with the help of bucketing. So again, GBs of the data, right? So let's say your location data is in the GBs, right? Let's say in the GBs, but the idea of buckets, right? Let's say even if your data in the GBs, in that case, you will increase the number of your buckets as well, right? Let's say you have 100 GB data and you have created only 3 buckets, 4 buckets. So still, right, there are huge amount of data in one single bucket. The idea of using bucket or creating bucket is to make it more granular, make it more smaller, so that we can optimize these kind of operations, right? So that is why this right, this batch size will be also very small, right? And this will be also very, very small. This will be very small. And since again I'm saying this mapper, right, this mapper will eventually reading smaller blocks, right, for the processing. And since these buckets are also very small, and here we are here for every mapper task, right, we are avoiding unnecessary data. So for this mapper task M1, right, only this data set or this bucket data was required, because whatever keys are mentioned here, 7, 5, 6, for that one data is not present in the M1, because M1 is processing these 2 buckets data where the ID values are 1, 2, 3, and 4. That is how this bucketing has leveraged this thing. So that is how this bucket map side work. And one important condition, right? In the bucket map join, data should be distributed evenly. That means if in the data set 1, right, in the both of the data set which you want to use for the bucket side join, the number of buckets in both of the data sets should be multiple of each other, right? It shouldn't be like the number of buckets, they are not multiple of each other. For example, in the data set D1, right, in the data set D2, if you have created 4 bucket, correct? So in the D2, how it should be? It should be 2 or 4 or like even 8, whatever it is, but somehow these two should be, the number of buckets should be multiple of each other, so that this data can be evenly distributed. And during this bucket size join operation, right, those many specific buckets can be sent to the specific mapper task, because our buckets would have been created on the same ID column and data is distributed in that fashion. So this is the condition, means the condition is number of buckets should be multiple of each other, right? So got it? Got this part, everyone? Awesome. Too much knowledge overloaded today, but that is something we have wrapped up our not yet, just hold on for a few minutes, right? I forgot about the sorted merge join, right? But quickly I will execute this part, right? We talked about the bucket map join, but we didn't executed it, right? So let's hold on for 5-10 minutes more and we will be done with our Hive, and that will be the wrap as well. And after that I will be giving you the projects for the 2 projects for the Hive. Everything will be shared with you all so that you can practice it. So in order to do the bucket map join, right, how it should be done? So 2 properties we need to set, right? First, obviously set Hive, which is already set, but still I will do it. Set Hive dot auto dot convert dot join equals to true, right? So first property is this one. Second property is Hive dot optimize dot bucket map join equals to true, right? So Hive dot optimize dot bucket map join equals to true. This property we need to set, and after that, right, we will be running you can say we will be running our join query, and again it should happen on the mapper side because it is bucket map join. But the runtime differences, right, you will not be able to observe it in a smaller data set, which is, let's say here we have added 4-5 records, but here the idea is to show you all those properties and make you comfortable with the understandings how bucket map side work. But previously, right, we were working on the sales data. So moving forward, whatever practice you will be doing, just try to work around that one, right? Use that heavy data set so that you can even see the performance related improvements as well when we perform the joins and all. But first, let's run this one. So here we can see numbers of mappers, but there are no involvement of reducers, and ultimately it is happening the bucket map join. So we have got our output. Right now we are going to see the one and last join, that is the sorted merge. And here I need help from you guys. Help as in, how many of you know about the sorting algorithms? Right now, let me test your programming and logical concepts. How many of you know about sorting algorithms? Right. So sorting is obviously, right. I'm talking in terms of the I'm talking in terms of the normal programming DSA, you can say, right? So bubble sort, yes. So different sortings you have seen, right? Insertion and then selection, vagera. And after that, most important, right? Majorly we talk about, let's say, merge sort, right? We talk about the heap sort, right? We talk about the quick sort. Cool. So these are the sorting algorithms we talk about, and the best time complexity, right, at max with any, like the optimized sorting we can use, that is the n log n. N is the you can say the number of elements. This is the best runtime we can get. Correct. Now talking about the sorted merge join. So if you remember, right, in the beginning I said, okay, let's just keep it sorted one, right? Sorted merge, simple, right? And try to add this thing, right? How it will actually work. So here how this thing is actually going to work, this sorted merge join. Okay, for this one we need to use the simple algorithm, right? And that algorithm is nothing, very simple. Let's say you have one array, right? One array, 1, 5, 7, right? 8, 9. So we have one sorted array. This is sorted, right? 1, 5, 7, 8, 9 in the ascending order. Just be with me, right? You will get the idea. And another sorted array. It's a 2, 3, 6, right? And then 10, 11. This is also sorted array. Correct? And let's say this, the length of this array m, and this, the length of array is n, right? So if I give you the problem statement that right, what you need to do, you simply need to merge these two arrays so that final resultant array is also sorted, right? That means merge these two arrays together so that we can get 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, right? So this is how, let's say, the result we want to expect. So generally, right, how it can be done, let's say the very naive or basic approach, let's say we have array 1 and array 2, simply create one more array, right? One more array 3, right? Which will be of size m plus n, right? Which will be of size m plus n, and add all elements from array 1, array 2, and then apply one sorting algorithm on top of it so that our final output is sorted, right? But in that case, the complexity we will be achieving will be n log n, right? So how this can be optimized in the linear runtime complexity, to use the basic approach of merge sort. Merge sort means how to merge two sorted arrays together so that the runtime complexity is the linear. So again, refer this one, the simple approach, how you can do it, right? Very simple to do. And that is how you will get the idea. One, and that is the simple thing is getting used in the, right? That is the simple thing is getting used in the sorted merge join, nothing beyond that. And this is the most preferred way. This is the most optimized way of doing thing, right? Even by default, ultimately, if you have enabled those properties, so Hive will use this sorted merge join technique for the join operation. 2, 3, 6, 10, 11, right? So let's say I have one pointer here, let's say variable I, and its current value is 1, right? And I have one iterator j which is pointing to this value, right? 2. So what I did, I compared whether this 1 is less than or greater than 2, right? I saw, okay, 1 is less than 2, correct? So in that case, I can just keep it somewhere, right? Let's have it somewhere. And I will increment my indicator to this one. Now my I is here, correct? So now J is still here because we haven't incremented it. Now this 5 will get compared with this 2. So obviously 5 is greater than 2. That means 2 will be added next to the list. And this J will now be pointing to 3, correct? Now this 3 and 5 will get compared. Obviously 3 is less than. So 3 will be added here and J will be moving on to this one, right? Now compare 5 with 6. Obviously 5 is less than. So my I pointer will move on to this 7. Now this will get compared. Obviously 6 is less than 7. So it will be added here. Now this J will point to this one. So here 7 and 10. Who is less than 1? Sorry, who is less than 10? 7. That means my I will point to this one. Now 8 and 10. Obviously 8 will be here and I will point to this one, right? And now 9 is less than 10. Obviously 9 will be here and we have reached the end of the array of 1. No other element to be added, but there are 2 remaining elements from the array 2. So I can just simply keep on appending it in the same sequence because this array is already sorted, right? So this is the simple phenomena or the simple strategy of using the merging part of the sort, right? So in this case, right, what will be the time complexity? I didn't use any for loop or nested for loops. Simply in one single run, I am iterating on this array, which of length m. And again, I am simply iterating on the second array, whose length is n. So runtime, or you can say time complexity, will be what? Time complexity will be simple, big O of m plus n. And this is linear, right? Linear means no power of n or no exponential or no logarithmic operation, right? So this is the best advantage. You can see, right, how drastically we have improved the runtime complexity of this operation. So same thing has been leveraged in this sorted merge join operation as well. That is why I drew this part in this manner, right? So here you can see, since while creating that bucket, right, there I added 2 keywords: clustered by ID, sorted by ID. That means first clustering will be done on ID column, and in each bucket the data will be stored in the ascending order, right, in the ascending order of the ID itself. Now you can clearly understand why we were doing that. We wanted to leverage this functionality, right? So in our first side, right, the users data, we can see everything was sorted: 1, 2, 3, 4, 5, 6, 8, pretty much sorted. But let's say by any chance this location table, right, we sorted it, right? We sorted it. Sorry, we did a bucketing on top of it, but we forgot to do the sorting part, right? So if that is not done, obviously our records will be in a different sequence. That is why, let's say 3 is present first, 1 is present first, 2 is present first, 4 is present first. Now let me in the chat box, if this is the case, will I be able to apply the sort and merge join? No, right? So how it can be done? Obviously this part also needs to be sorted. So that means whenever I will be creating my location table, that means this data needs to be sorted. That is why I will use I will add the sorted keyword, right? So here now how my data will look like: simple 1 comma UP, 2 comma Bihar, 3 comma MP, 4, AP, and same will happen here. 5, Mumbai, 6, Jharkhand, 7, Goa, right? And now this is part, right hand side is also completely sorted, left hand side is also completely sorted. And when we will join these two data sets together, our Hive will use the merging approach in order to join these two data sets together, because keys will be same here. So that equality match we were doing here, right? This one, comparing value of I and j, that can be done very, very easily. And both of the pointers can be incremented simultaneously. So that is the part of the sorted merge join. Now quickly I will execute this one and will tell you that what all properties we need to set for this one. So first property, set Hive dot enforce dot sort merge bucket map join equals to set Hive dot enforce dot sort merge bucket map join. Second is the Hive dot auto dot convert dot sort merge dot join equals to true. Dot auto dot convert dot sort merge dot join equals to true. Set Hive dot optimize bucket map join equals to true. Last is Hive dot optimize dot bucket map join dot sorted merge equals to true. Let me verify it again. Hive dot enforce, Hive dot sorted merge bucket map join, and Hive dot auto dot convert dot sort merge dot join. Hive dot optimized dot bucket map join equals to true. Hive dot optimized dot bucket map join dot sorted merge equals to true. Sorted merge equals to true. Now let me just run our join query. So select this one, let it get executed. Cool, right? So this is our join, which is done pretty quick, correct? So here you can see no involvement of the reducers again, and everything is done pretty fast. So cool, clap, clap, clap. Our Hive part is done. Everything, most important things we have covered. And as I said, this class is something which was pretty much important, right? And whatever I have taught about the bucketing, partitioning, and all these things, you need to definitely work on it. You need to revise it. Now, what I'm going to do first, my task is to just share all these things, right? This one, these properties and all to the, I will add it in the GitHub repo part. And after that, what I'm going to do from your side, right? There will be 2 assignments, correct? And I'm going to add those 2 assignments in the GitHub repository, and this GitHub repository link you can find in the resources part, correct? And I will share the details which assignment you need to work on, and you will find it in your dashboard, right? So that you can simply just look into it, that how it is like working, and you need to complete all those assignments and submit it. And just for the announcement tomorrow, so Shudhanshu will be starting with the HBase, and as soon as HBase is covered, again I will start with the Kafka part, right? So that will be completed. Then I will be teaching the Spark, and before even, I guess maybe after Kafka, I can cover the SQL part, right? So that is how we are going to proceed. But the next session, tomorrow one, will be taken by the Sudhanshu sir itself. So yeah, that will be a class for the NoSQL databases, and our starting with the like HBases and these kind of NoSQL databases. All right, so now it is time for the Q&As, right? Let's start with the Q&A part. And yeah, over the call, I will keep on pushing these changes, right? Whatever query I was running, right? That is something I will keep on posting into the GitHub, and you will get it at the end. Awesome, right? So 2 projects you need to do, guys. So one is basically for the chat related data. So there you need to consume the data, create the table, and you need to perform some queries on top of it. And one data set will be for the traffic violation. So that will be also a pretty big data set. And there cool problem statements we have given to you in that document and that assignment or project, you can say. So both of the things you need to complete, you need to submit. And before that, last time we were running the challenge. This time, right, we right, for the challenge one, right, the assignment I gave it to you. Please complete it as soon as possible, submit it, so that you are also eligible to win the prizes. And yeah, that is how it should be. Cool. All right. So projects, right? You see, guys, projects, we have taught you everything. Now just do the projects by your own, right? If even I am creating project for you, then what is the meaning of learning? Tell me this thing, guys. You agree with me or not? Should I complete the project for you all, or you should complete it by your own self? Correct, right? So my main purpose is to teach you in depth everything, so that you can utilize those learnings to complete the task. And if you are stuck anywhere, then obviously we are there to help you, right? It's not like we are just going away and we will not be helping you anything in the project. But idea is to push yourself, right? You need to take that responsibility. Yes, I have read the fundamentals, now I will just do it by my own, right? That should be the enthusiasm, and that should be the energy to learn anything. Okay, so let me go into the participants. Cool. First, I can see Ravi. Yep, man, go ahead.
Hello, sir. Am I audible?
Yes, I can hear you.
Sir, as you told that whenever we create a table, we have to specify data type, okay? And when we created a table and we specified it as int, okay, integer. And when we और क्या कह सकते हैं, जैसे कि अगर हम उसे पाइथन में अगर यूज करते हैं तो क्या उसे वो स्ट्रिंग में ही लेगा या फिर इंट में लेगा वो?
Yes, it will. That's why I was saying stream. See, stream क्या होती है ना? Stream always comes in the form of the like string bytes, right? It doesn't come in the proper, you can say, its data type. That is why it needs to be handled separately in the Python code, and it needs to be returned as a output in the same fashion, right? So that Hive can handle it.
Okay, इसका मतलब कि कोई भी डाटा टाइप हो वो स्ट्रिंग में ही उसको इनपुट देगा.
Yes, that will yes, when you will be using that transformed, right? You can say transformed or UDFs, right? Then in that case, the whole record, that whole row will go. If you are using like all the columns in that transform function, the whole thing will go as a string, you need to do the splitting and all, and then do your operation and then return it in the same fashion. So that is how things will be done.
Okay, sir. Thank you, sir.
Cool. Next, Rupesh.
Yeah, hi sir.
Hey.
Sir, yeah, you told about the UDF, Python UDF, but suppose there is a in background it's a program is converted in the map reduce. So how the Python program is converted in the map reduce, and if our process in the distributed node, so how the JVM program is going on the each nodes and how it will be converted. I am little bit confused about the process
Can you repeat
about the
again,
UDF.
please? Can you repeat again?
We are working on the Python scripts for the UDF. So how this program is converted in the uh, map reduced form, and it will execute on the distributed manner in the
So
different
see,
different nodes.
map part is getting executed as it is, right? So let's say you have written one Java code, right? There you imported few libraries, right? And obviously that will be treated as a mapper task. You would have written the mapper function in it, correct? That is how it was going on. So similarly, what you have done here, you imported or you added that Python file in the Hive shell. So now that means it is something which will be imported in all those JVMs where your mapper tasks are running. Right.
Okay.
So that is how it is happening behind the scenes. It's not like that is a shared code which will be used by all those mappers and all. It is something which will be available for all those like mappers in which individual JVMs they are executing.
Yeah. And one more question: how the UDF impacting our performance? Means can you means
That
Java UDF is Scala UDF or Java UDF is more optimized or Python UDF is more optimized?
it is not like that which one is optimized, because see that will something will depend on the, it's not dependent on the choice of language, right? Scala can be done, your right, Python can be done, but let's say there is with simplicity, right, in your program and in your functions where you are not supposed to work more on the object oriented things, then there what is the need of creating those objects and garbage collection related things? Just do a simple thing, right, and come back. Obviously Python will be handy on that part, but it will depend on the cases, but it has no relation as of now. I haven't seen or heard anything where okay, Python UDFs will give the bad performance and Java will be giving the good performances. I think it's not like that.
Okay. Okay. Thank you, sir. That's all for my. Yeah.
Cool. Guys, can we take a 10 minutes of break? I'm pretty much exhausted. And then we can start the Q&A if that is fine. Thank you so much, guys. Hello, everyone. I am back again. So let's start with our Q&A part. Okay, next is Prashad. Please go ahead.
Yeah. Yeah. Good afternoon, Shira.
Hey,
So,
Prashad,
yeah,
can you
I
hear
have.
me?
Yeah, I can hear you. Can you hear me? Hello.
Hello, Prashad. I can't hear you. Okay, let's go to Yashodhara. Yashodhara, can you hear me?
Can you hear me? This is Prashad.
Oh, I'm really sorry, guys. Hey, can we start from Prashad? Prashad, can you
Yeah.
please start?
Yeah. Now I can hear you. Yeah. So, yeah, I have a couple of questions, Shira.
Please.
Let's say, suppose I have the 10 millions of data in my data set. So, if I am trying to create a bucketing, so can we how can you justify these many bucketing we require to process these 10 millions of data?
That's what I said, right? The requirement is, again, in the beginning, I mentioned that is something which will depend on the size of data you are also having, right? Even let's say you are having 100 GBs or terabytes of the data, right? So in that case, obviously, you need to at least increase your bucket number in such a way so that at least not, let's say, 50, not very huge amount of data is stored in one bucket, at least in the minimalistic way, right? So that it can be handled by your mapper task, right? And it can be fitted into the memories, right? Even the single bucket which will get created. But for the columns, as I suggested, you should definitely prefer the IDs column because that will be more randomized. And in that case, you will not even see the skewness in your buckets.
Okay. Okay, yeah, got it. And one more question, suppose, let's say I have the data set and the column is like a country, so I can able to create a partition on top of this. Suppose, let's say if I don't have any column called country, like my data set is employee ID, employee name, and mobile number. This is my data set. In this
Sorry,
case,
what is your data set?
yeah, employee ID, employee name, and mobile number. So these are the three columns only is there. Suppose if I want to run a query on top of this one, so before running a query, can we create a bucket or can we create a partition on top of
Yeah,
this?
bucket in that case can be created because you have the employee IDs and all, but partitioning will not be possible because even name, most of the time it will be different. IDs, obviously they are different. Mobile numbers will be also different, right? So the idea of to have the partitioning key where you see more like not that unique columns, right? Or the values in that is the whole thing, I would say. Right, so that is how in this table bucketing you can apply, but that part you can say, what do you say, the partitioning is something which cannot be added.
So suppose let's say I have the 4 buckets has been created. If I run a query on top of the these all the buckets, suppose these bucket information will.
Yeah, as I said, right, Prashad, bucketing is not going to help you anyways in your table scanning or data scanning. In the beginning I mentioned this part, right? Here only partitioning can help you. Bucketing will help you mostly in these kind of operation, optimizing your joins and other things.
Okay. And last question, currently we are using a temp on on the Hive class, the directory we have been created. In a real time, are we going to use the same temp in the file?
No, not same temp. So if wherever you are not getting read permission issues, you can place it that file. Simple. It can be your /home/Prashad/ some directory. But temp is something where most of the read permissions are not applied. So things can be read from there easily.
Okay. So if I run a query on like a partition or a bucketing wherever it is, suppose this partition and bucketing path will be get stored in name node.
Sorry, which one?
This partition or bucketing
Yes,
information.
yes, everything. This metadata will be like maintained by that one.
Okay. Yeah, that's it from it. Thank you.
Cool. Next, Yashodhara, please go ahead. Yashodhara.
Hi, Shyam. I got my question. They're the same one.
Sorry?
Hello, can you
Yeah.
hear me?
Yeah, I can hear you.
Yeah, I got my question. They are the same one. It is
Okay.
asked for the question, I think.
Okay. Okay.
Thank you.
Next, Mohiuddin. Sorry, dude, if I mispronounce your name, Mohiuddin, right? Hello? Mohiuddin, can you hear me? I have asked you to unmute yourself. Can you please do that, Mohiuddin? Okay. Rajbir, please go ahead.
Yeah, hi, good afternoon, Shashank.
Hey.
My question is, we used insert command to load data from one table to another, right?
Uh-huh.
This is one command, and there is another command from table insert overwrite table and that. So, what is the difference between these two commands? Are
there is,
same? Or?
there is no difference. There is no difference. They are same,
Okay.
just like a synonyms. Simple.
Okay. So this question is just for the clarification. I just wanted to understand whatever I am thinking or understood is correct or not. So select statement always give the output in the form of string, right? Whether data type is integer or string. So it will be printing on the console in string form, right? Always tab separated.
Can you repeat?
Okay, my question is that whenever I run any select command, let's suppose select star from table, limit 5. So whatever 5 result will be shown on the console, it will be in the form of string and tab separated, correct?
Yes, correct.
That is the reason in the UDF they are considering string while taking the input from the console, correct?
Yes, exactly.
And later on in the internal structure, whatever we want to perform on the integer or string, we typecast accordingly, and at the end of the final output returning to the console, we again change everything back to the string.
Yes, correct.
Okay, so understood. Now next question is that these all are temporary changes, correct? UDF applying on the data. So can we do permanent change also in the data set with the help of UDF? Like multiplying order with the 100, so every value will get changed.
What you are saying? What we can apply?
So let's suppose we are applying the UDF on the order column. Now we are applying 10, multiplying with 10. So every value will multiply with 10 and output will be shown on the console.
Yes.
So it will be a temporary change and showing on the console, or in internal table data will also get converted accordingly.
No, so that is something we are that output we are seeing over the screen, right? That is, we have applied the select query. If you have, let's say, another table, right, which is having these 3 columns, right, which we reflected in the output, you can do it in this way, like insert into that and select this particular operation. Then in that case, that transform data will go to that table. But at this moment, it has nothing to do with the original table. It is just a select operation.
Got it. That's it. Thank you.
Okay, awesome. Next, Venkat.
Yeah, hi sir.
Just one more thing, right? So that assignment, right? 2 assignment will be there, and that will be uploaded in the GitHub and in your dashboard assignments, everything. So make sure you complete it, right? You don't miss it. Yes, Venkat, please go ahead.
Yeah, that assignment is the project that you're talking, right?
Right. I will be giving two today.
Okay. So the thing is, here we added our Python UDF file to our Hive right now, sir. So I got a question like, how Hive internally knows whether the file is in HDFS or in what to say, like LFS? Will it do any scan on that?
What like I didn't get your question, right? With respect to which file you are asking?
Yeah, UDF we have created right now.
So
See,
yes, UDF is something, right? That is not a data which needs to be stored somewhere, something, right? That is something, a kind of a package, right? Which you can say basically where, let's say, Hive services are running, right? That is also one of the JVM processes. So that will go to there, right? It has nothing to do with that thing. Let's say that UDF file will also, we have added it. So that will also go to some HDFS location and will get stored. No.
Okay. So the one thing, see, if we previously we dropped the internal tables and external tables right now. So is there any way to bring back the drop tables? Like,
is there any way to bring back drop tables?
Yeah, the drop.
So a drop table, no, there is no way to bring back the dropped tables. Truncate, or even like if you have dropped something. So this is something which can be reverted back from the HDFS side, right? So in HDFS, even when you run the RM command, Hadoop fs-rm command, so that data is not deleted from HDFS instantly. That will be moved to a trash location. So any point of time, if you want to revert it back, you can do it. So since even right, this is not the way like Hive will be working, because Hive will completely drop means something which is getting that will be flushed from the HDFS and the metadata itself. But you can check the temp location, try it out in your local machine, right? Just try it out. If you do the drop table, whether you are able to see that one in the trash location or not.
Okay. Like, so you said like what to say? We have by using sort merge, the data will be sorted, right, in the buckets. Like IDs will be stored in the sorted order 1, 2, 3, 4.
Yes,
So
yes.
as we know the IDs now, we can say that this bucket can move to this mapper. Like mapper 1 has IDs 1, 2, and the bucket first bucket has 1, 2, 3, 4. So if we don't know the IDs, what how it will happen, sir?
So if you don't know the IDs, then you don't know the column where you need to apply the bucketing. You cannot do the bucketing. Simple.
Okay then. Thank you. Sir. Okay, sir. Thank you.
Cool. Thanks. Next, Sheshadri.
Hello, Shashank. Good afternoon.
Good afternoon.
Actually, today's class was great. I got the concepts, but I have doubts related to last Sunday since I couldn't attend regarding the partitioning. So in the partitioning, actually, we are creating the dynamic partitioning, right? So as you are told that it will do a full table scan and we will run the queries then. But like how can we individually select that particular partitioning from where we want to run the query in the?
Yeah, so you can see the main purpose to create the partitioning, select star from where that column name, right, which you use for partitioning, and mention that value. So the main reason to use partitioning was the same, right? We can point our query to specific data part which we have stored in the Hive and just process on that one, right? There is no need of the whole table scanning to filter out or do something.
Yeah, yes, Shashank, I got it. And another query actually I had, like I think it will help a lot since most of the freshers like who have joined some particular company, if they have nearly experience of 10 months, but they have not worked on some particular technologies or they have not been allocated technology to work on. So, would you suggest like to do a switch or let them remain in the same particular organization till the particular bond period is completed?
So how like the bond period? What's the for that one, the length?
Yeah, Shashank. So it's nearly for 2 years for me the bond.
Yeah, so 2 years is something, right? So what I suggest to everyone, if something which is affordable, right? If you can afford to give back that money, right? So that can be done, right? Don't stay in that company. And even there are companies I have seen, right, which are willing to do the buyback, right? Buyback means, let's say if you are into any kind of, if you are in any kind of contract or the bond, right? And your current employer is asking for that money. So the new company which is hiring you, right, they will tell you that, okay, we are willing to do the buyback. So in that case, simply whatever money the first company will be asking to you, they will simply pay that money. You don't need to pay anything. You can simply put down your papers and move away. So that is how it is being done, because when companies are in the real need, right, so they need to hire folks quickly, and right, that is why they are able to just pay that money.
Okay, good. So Shashank, but we should mainly work on our skills, right? If we are doing a switch within a year or within 2 years, right?
Yeah. Like, just target your domain first, in which you are good at and you have a good expertise, and then look for something else.
Okay. So Shashank, and another last question actually. So regarding the challenge, so mainly it should be performed using the partitioning, if I'm correct, right?
Yeah, right.
Okay. Yeah. Thank you, Shashank. Okay.
Cool. Next, Srinath.
Hi, Shishan.
Hey.
3 questions. One is all along, like, many places you're using the set command, right, to set some of the properties. Is there a list that is easily available? What each of them does?
So that is available on the official documentation page of Hive, right? So if you type, let's say, Hive properties, so you will be redirected to the official page of apache.org.hive something. So there you will get the complete list, right? There are tons of properties, and not everybody, obviously that is something nobody can remember, but yes, it is listed there with the proper explanation. So you can refer it any point of time.
Okay. The second one is when you are doing the bucketized table, right? You inserted from the other table that you created earlier. Is it okay if we directly, get it from the file, the CSV that you had, instead of through another table? Is there anything specific about this?
So for this one, right, the direct data is something which cannot be, right. So I'll tell you this way. So in these data sets, right, the direct load cannot actually happen. So we should have that first loaded into something, right, and then let's say from that table we loaded it into the main partition table and all. Then we are done with our thing, and we can remove that one. So main reason is because when we write, or when we are supposed to these things, right? If you remember, when I talked about Hive is something which is schema on read, correct? So schema on read means as soon as you create a table, right, you can simply dump that data.csv and all. Probably in the beginning, right, in the initial days, right, first, like last class itself, you would have seen I was getting some error. I created a Parquet file and I directly loaded data into its CSV without any other table, and I was getting error while querying it, right? So why that was happening? Because Hive is something which is schema on read. During the write time, right, when you are writing the data, it will not do any validations, correct? And that is the reason when you are, let's say, just doing that kind of load operation, not insert one, I'm talking about the load operations. So that time the validation will not happen, right? So since in the partitioning, and you can say in the bucketing, we have other properties which you have enabled there, let's say partition by, clustered by. So during the insert time itself, right, that Hive engine or table should know, okay, this record I have got, where I need to put it, right? So in order to do that one, that is how the other tables help is needed, so that the data can be pushed into the bucketed or partitioned one.
Okay. Yeah. The next one is the concept of views, etc. That cannot be utilized in such situation.
Which one?
View, table views, right?
Table views?
View. Yeah, view.
Okay, view. You are
Yeah.
talking about.
Huh?
You are talking about hue or view? What?
View, VAW, view.
Can you type it in the chat box? Maybe I am just not able to. View, yeah. So view is something which should be created on the final table, right? That is something, it is not a original table, right, with properties. It is something which is just you can say abstraction of the main table where you are giving something to the external audience, right, to query it. So that's how it should be.
The last question is, I tried the multiply, the first example, right? Just the Python code. The Python code doesn't seem to work actually in the Cloudera instance that,
So
yeah.
there maybe what you can do, you can first try to check whether Python is eventually installed in the system or not. Just try that out once. But still, let's say if you are facing any issues, please share the screenshot with me over the mail. I'll look into it.
Okay. Actually, it doesn't give anything, like, it just returns, just a cursor will come, whatever I type, the numbers, nothing happens. It goes to the next line. If I type again, hit enter again, goes to the next line. There's nothing happening.
Yeah, share
I
those
just,
screenshots. Yeah,
yeah.
share those screenshots with
Yeah,
me.
I just did the, just the print command. That print works, but none of the, especially that first line, the standard IO that you have, right? That is not, that doesn't seem to work properly. Okay. Yeah, I think that's it I had. Yeah, thank you.
Right, cool. Next, Satish. Hey, Satish. Satish, I'm not able to hear you. Not able to hear you, Satish. Yog, please go ahead.
Hello.
Hey.
Hello, Shah. So actually, I have like 2-3 doubts with today's lecture. So first doubt is like when you started explaining the partitioning part, right? Sorry, bucketing. So you gave an example of the just a common example of that balls thing, and you said like red 3 colors. So 3 buckets were created, and each bucket had its own color. And then you were explaining about the length thing where 3 length was in one bucket, 4 length one, 2 length one. So like what I was not getting is like if we are like having 1 million suppose or like a large data, and you mentioned that bucketing should be on the ID, like unique randomness and all. So like if we are having like 1 million ID, does that mean like 1 million buckets will be created? Like,
your voice is very low, Yog. Can you please speak a little bit?
Are you able to hear me now?
Yeah.
Yeah, sorry for that. Like what I was asking is like if we have like a big data and like if we have like 1 million IDs in that, so does that mean like 1 million buckets will be created? Like how does it work?
No, so in buckets, buckets will depend on that value, right? I written clustered by ID, sorted by ID into bracket some number bucket. So the number which you will define during the create one, only those many number of buckets will be created, and Hive will decide based on the hashing, okay, in which bucket that record should go to.
Okay, so it will consider the ID column, and then we are giving that number, and then that many buckets will be created.
Yes.
So like in individual buckets, the data will be like assigned based on the query we are giving, like how does it work?
So bucket means when we are loading the data from that another table to this table, right? The bucketed table, that time Hive will decide it, okay, this is the table where while creating it, we have mentioned some clustered key and the number of buckets. So under the hood, it will use the hashing algorithm, right? Simple, anything which can distribute the data evenly, right? You can do more exploration about it, that how hashing is being applied on the backend side of the bucketing in Hive, right? Then you will get more idea about it, because that is something which is a very broad topic to discuss as well.
Okay. And another doubt is like when the first time when you created the on your terminal, you were showing that from the warehouse that 001 and 002, that two buckets were created. So what my doubt is like, you created two things, DNA and FCS. So when those two buckets were created, I was little confused, like why all FCS is not in one
No,
bucket
not all
and
FCS were
DNA.
not at one place. I can even show it to you
Yes,
again.
yes, that's why is it like that? It should be in one place, or like how does it?
No, so I have used like the ID column, right? Let me show you if you are confused, right? Not all FCS values are. So here, just look at this data, right?
Yes,
001,
yes.
few values of FCS, and here is also one record FCS.
Yes. So this is what like what I did, like little confusing, because I thought like
No, so
partitioning.
the column we will be using for the bucketing, right? Only that one will be used to decide, okay, where it should go, not any other column.
Okay. And one last doubt was like, when you said that set hive.auto.correct.thing is equals to false. So like, can you repeat why you selected false there? The first time when you used that property.
Which one?
Set hive.auto.correct.join is equals to false. So like, why did you use false there? Like,
So because there we wanted to use the bucketing map join and the sorted map join properties separately. That's it. That one combined property we turned off and individually we turned it on.
okay. And you were explaining about the joins, left join, inner, and also that was like that theoretical part was pretty easy. And when you started about Hive optimized join, and you explained that 4 different things, map, reducer. So this left, right join, what you explained, that is
So
happening.
that is the simple. That was something to explain you the join happens, but the bucket join and all these things means in the join operation, bucket map strategy will be used, and that join can be anything: inner, left, right, outer.
Oh, okay. Okay. Thanks. Thank you.
Next is Shripad.
Hi, Shashank. So I have like a few doubts. First one is related to the bucketing. So for bucketing, do we need to define it in the table creation time, or else can we like use an alter table and try to define the properties for the
Yeah,
existing?
it needs to be used at the create time itself.
Okay, so if I want to apply a bucketing strategy for both the tables which are I'm going to do the join, I need to create a new
New
separate
one.
tables
Yes,
for both of them.
new one, correct.
So dump the data into that tables and do the appropriate operation.
Yes.
Okay, and the second question is how should we decide which type of this Hive SQL joins we need to use, like bucketing joins we need to use. So you
So
mentioned certain criteria like data sets should be small for reduce side, and one data set should be small for on map side join. But in reality, how should we decide that? Is there any
No,
particular?
so that is how it is decided in the reality, right? Whatever I talked about in reality, we decided, okay, we see, for an example, let's say I am working on the e-commerce data set, right? So there will be orders table, those will be big enough. There will be transaction table, big table, payments will be there, very big table, but there will be product category, let's say, right? There will be, let's say, locations related, there will be customer related, there will be merchant related. Those are something which are smaller in the data sets, right? So because not so many attributes will be included there, and that is something which can be even moved easily to the right, the mappers. And this is something also being called as the dimension tables, where right, the facts are not stored and the size is also very less. So based on that one, we always decide, okay, which one we should go for.
Okay. So my next doubt is, so in the explanation related to this UDF, right? So you used the syntax add file. So I think one person previously asked, so I just wanted to elaborate that. So add file is being used. So previously we used to load load the data using load data local. So we will be able to differentiate whether it is coming from the Linux local or it is coming from Hadoop with that syntax load data local. Hive will be able to differentiate. Then in this case, add file, how will it differentiate? So supposing which path I'm giving, so whether from Hive or from local. So that's
Okay, cool. Thanks for that. All right, Abhishek.
Sorry.
Yeah.
I think I had a doubt actually on that.
Okay. I thought you were explaining something. Yeah.
No.
So what was your
So
doubt?
yeah, I had a doubt between those how it will Hive engine will take the thing.
Can you come again, please?
So my doubt was, so we are using add file, right?
Add file, yes.
And generally add file it doesn't have any differentiator, like a indicator that data is coming from whether from the HDFS or whether it is coming from the local Linux.
Right.
So but load data, we have that differentiator. Load data local means it is coming from Linux, and load data means it is coming from so how the
Yeah, so
Hive
add always means, so see, load keyword knows that the data can come from either HDFS2 or the normal one, but that one, the add is always supposed to move something from the local to the Hive engine, right? It has no any other option to specify, okay, this is coming from HDFS and others.
Okay, so it is we should consider it as local only.
Yes.
Okay, so last question, about the assignment, deadline, right? So last week, whatever you have given assignment, you said that today Saturday it is going to be a deadline. Is it correct, or whether is there any other date?
Yes, so few of the folks are not able to submit it, right? So that is why again I'm saying this is something, right? We will always take a buffer on that one if people are not able to submit it. So just whosoever has completed it, that's pretty good. But you can submit it in the middle next week as well. No problem.
So, and do we need to record the video as well? So how because there is option for record.
Not that one
For the main assignment also.
Yeah, so that next one I will be giving, right? That will be available to your dashboards, right? So there you need to come up with that decent project report as well. Okay, yes, this is how I did. Okay, all these commands, this is what we followed, and these kind of optimizations I added, and all these things you need to cover.
Okay. Thanks.
Next.
Hi, Shashank.
Yes, Sripat, please go ahead.
Abhishek here, not Sripat.
Oh, hi, Abhishek. Yeah.
Yeah. So, Shashank, I have a question around when will be that Neuro lab will be accessible? Actually, my local system is having some issue.
Yeah. So that is something which will be available very soon. As I said, right? Team is working really hard, right? So just allow them some time. I had again a chat with Sudhanshu yesterday. So they are trying to integrate it in this web platform so that, again, this is not the only batch which needs the lab environment, right? Other batches we have for, let's say, data science and all those things. So we are trying to make it live as soon as possible, and team is working on it. So just wait for more, like 1.5 week to just get access on it.
Okay, got it. Just in case, actually, as we have to submit that assignment, isn't it? do we have any like online platform where I can like do this Hive thing or like complete my assignment and then can submit?
The Hive part.
Is there any?
No, as of now, I don't know anything where you can just get the full Hive environment.
Okay, okay. So how should I go about it? Actually, my local is like not working and due to
So
some
maybe just wait
constraint.
for that time. Like once the lab part is available, then like you can work on it and we can reassess this one. So not to worry about on that part.
Okay, got it. And regarding that Hive thing, actually, so as you've explained, difference between partitioning and bucketing. Okay. So let's say in industry, when you have like, as you have mentioned, we have facts table, we have dimension table. So as Hive is not a data warehouse, but you can say so. It's an engine that will process all the things, whatever is in your data by the help of HQL. So let's say if you have like one dimension table that is also like being categorized into, let's say, some what I can say, the dimension is like heavy, but like your facts heavy means like you have categorized it on the on the basis of products and all. Okay. And your facts is having like let's say million or million rows or something. Then how basically you will be able to categorize the differences between partitioning and bucketing in the near real time actually?
No, near. So see, I think I'm not sure whether you are pretty much clear about the partitioning and bucketing. So you need to understand the differences, right? And based on the differences, what is your requirement at that moment, right? So in my requirement, for an example, right? Let's say I have a huge data set and I don't have any requirement where I need to do the joining operations. I am always supposed to filter some data and doing the group by operation. So definitely I will go for the partitioning part. And partitioning, I will decide if I know, okay, these many distinct values are present in this partition column, I can use the static partitioning. If I don't know about it, I will simply use the dynamic partitioning and will let Hive decide, okay, how many partitions will get created, right? But on the other hand, if in my use cases, I have a need that time to time, I will be getting huge amount of the data set. And along with that, I frequently will be doing the join operations. So I need to apply both of the things. I will be doing partitioning as well, and I will be doing bucketing as well. So partitioning, again, bucketing, both runs differently, right? Both are not dependent on each other, but both can be used together. So if I have applied the partitioning, if even on that data set, I want to do the filtering, frequently grouping, I can do that. If same data set, I want to use it for my joining purposes, optimized joins, I can use it because my same data set is partitioned as well and bucketed as well. So that is how you should decide, right? Based on the volume of the data, based on the your use cases and how your like normal queries are performing, right? So that is how you figure out.
Okay. Got it. Thanks, Sam. Apart from it, like there is one more question. Is there any kind of execution plan or something like that in HQL so that we can understand what's going on behind the scenes?
So for that one, you can run that explain command, right? So explain command actually gives the whole output of what is going behind the scenes.
Okay, got it.
Yeah.
Yeah. Thank you. Thanks, Sam.
Cool. Next, Sujit. Hey, Sujit, please go ahead. Sujit. Sujit. Anyways, Shubham, please go ahead.
Yeah, hi sir. Sorry to interrupt.
Yeah, tell me, Sujit.
Yeah. My question is, you you have talked about UTF, right? UTF function. What if I want to like multiple UTF file, like py file. So how can execute in say a table? if there is a
so if those UDFs are present in different Python files, right?
Yeah.
You need to import all those Python files. If you think that there can be multiple things, right? You need to pass. So you can try to have it in one single file as well.
But maybe there is a multiple file. Then can we add like multiple transform in a single query?
Yes, you can do that, right? So see, in the one file, that code, right, which was written for line, the standard input, right?
Yes.
That will be the common code, and from that for loop, as soon as you have extracted one line, you can simply pass it to the multiple functions. You can write multiple functions within the same code, right? And you can call it, and one by one you can try that out.
Okay, got it, sir. I will try.
Hello, sir.
Yes, please go ahead.
Yeah, sir, I'm facing one issue with the sorted merge join. So before that, till the bucket map join, it was working fine. It was showing the result properly. But while doing that sorted merge join, I set those 4 parameters as you mentioned, and then I did that the same query. But it is showing like no result. The map reduce is working. Then after it is just saying okay, and then done, like time is elapsed or something.
Okay, so if it was working for map and all, it should work for sorted merge and all, right? There shouldn't be any issue, but that can be checked. You can share these screenshots with me and share the screenshot of the data set as well, which you have created, the create table commands, right? And I will look into it, what is wrong you are doing.
Okay, sir, but if the bucket map ran fine, then that means like all the data sets are working.
Yeah, that is why I'm saying, right. I mean, that is, since it was working, so I also need to look something was working and why now it is not working. So those error logs is something which you can send to me, and then I can look into it.
Okay, sir, till there is no error here, like it's normal, so I'll just send
But at
you
least
the
whatever
screenshots.
data, whatever data and other things you are using. And did you try, if it is there, just send me, right? I think without that one, I won't be able to help you.
Okay, sir, your mail is like
Shashank@ineuron.ai.
Sir, one question I have about sorted merge join about
I can't hear you properly.
Okay, so now
Hello.
Hello.
Yeah.
Okay, sir, I just have one question about sorted merge join, like about the concept that how like it is better than the bucket map, because sorted merge it will try to sort the stuffs out, right? And the same thing like like M1 and M2 bucket of user will get the first bucket, the L.P1 of the locations, and it is doing the same thing, and one extra step is getting added of getting sorted thing, right? So how it is like
when we are doing normal bucket map join, right? So for the join part, correct? So for the bucketing and all those things, let's say, have been done, but the specific join part where those keys should get joined, that is being done by the backend hashing part. But when we talk about the sorted merge join, right? So there will be no need of the backend hashing in order to match those keys together. It will be simply a application of merge sort, which I was talking about, that will be used, and it will improve the query performance. So that is the difference.
Okay, because the things are sorted, so hashing and stuff not required. It will be doing like one-to-one.
Yes,
right?
yes.
Okay. Sir, just one, just a couple of small questions. Sir,
not able to hear you, Shubham. I'm not sure what mic you are using, but I'm having very hard time to hear you.
Okay, sir. So now is it fine?
Yeah, tell me.
Okay, sorry, sir, for the disturbance. My mic is not visible, but I'll just how we can see those properties that we are setting. Like we are using set command to set the properties. I searched on internet, but I didn't find any view command.
So just search for Hive official documentation page, right? There everything is mentioned, all the properties are mentioned there.
And these properties get restored when you start the Hive cell again, right? By to default.
For that one, you can write .hql file and mention all those properties there. And every time you are starting your Hive, just pull it every time. And that is how it can be automated.
Yes, sir. That's fine.
Okay. Next, summary.
Hello.
Hi, summary.
Hi, Shashank. So my question was actually the same one that with the Python. I created a simple UDF. I have also sent you the screenshot. The input part is not working actually. So all the functionalities are working in this Cloudera environment of Python, but that input we are taking through stdin, that is not working. The program is getting stuck. If you are typing a string, it's not performing the transformation only. So I have sent you the screenshot also, as you mentioned, and then just have a look into it, please.
Sure.
And the second part is that, like you mentioned, that partitioning and bucketing can be done at the same time also. So I wanted to know that if we partition a table, so we have partition and also we apply the bucketing. So we'll write in the end like partition by this column.
Yeah,
and
first we will start from the partition by, then clustered by, then sorted by into some number and bucket.
Okay. And then the directory structure will be like partition first, and then inside that there will be buckets, or buckets first.
Yes. First partition, then buckets.
Okay. Okay, that's fine. That's all.
Next, Omkar.
Hello, sir.
Hello.
Sir, in last lecture, you use Hive underscore class underscore B1. And in this lecture, you use Hive underscore class underscore 4. Is it same?
No, it is a database, right? Database I have created in my system. You can create a database in your system and you can keep on using it. There is no difference on the database level. It's just I created a two things, simple.
Okay, sir. That's the first. And the second is, sir, जैसे आपने UDF में जो फंक्शन लिखा था पाइथन में, एंड बाद में उसे UDF पे अपने मतलब UDF के हेल्प से आपने वो ORC के फाइल में अप्लाई किया और हमें आउटपुट मिला. तो सर हम जो भी फंक्शन लिखेंगे पाइथन में, तो वो सारे फंक्शन उस पे अप्लाई होते हैं क्या ORC पे?
हाँ, जो भी लिखना चाहो, because whatever you are doing from that select command, right, using transform and all, because that will go as a simple string stream. It has nothing to do with the ORC and Parquet and all.
Okay, sir. That means whatever programming we will done on Python, that will automatically come on that ORC.
Right.
Okay, sir. And sir, I have a doubt regarding assignment. सर मैंने मतलब जो क्लाउडेरा का हमारा ये है उस पे ना मेरा एक एरर आ रहा है. मैं पढ़ के बताता हूँ. रिटर्न कोड 2 from org.apache.hadoop.hive.ql.exec.mr.mapred task.
स्क्रीनशॉट भेज दो.
स्क्रीन शेयर करूँ क्या?
स्क्रीनशॉट भेज देना
मेल पे.
हाँ, मेल पे, एंड क्या इनपुट यूज कर रहे हो उन सबके साथ में.
ठीक है सर, मैंने ये करके लिया है. मैं स्क्रीन शेयर करूँ क्या 1 मिनट के लिए?
Screen share will take time, right? Because that is something I need to look into it, and other
okay sir, no problem. I will send a screenshot on mail.
Also waiting for Q&A.
Okay sir, okay. And sir, one more, मतलब हम हमारे क्लासमेट के साथ इंटरेक्ट नहीं कर सकते क्या?
Not sure, like, because we don't have any grouping kind of mechanism, right? Because
no, ग्रुप नहीं बनाने, लेकिन अब जैसे कि मुझे एक छोटे मोटे डाउट्स है,
If you have like knows separately each other by any means, just be active on LinkedIn, because whenever I give a challenge, right, so those folks will be posting, so you can get to know who is enrolled in that program and you can just connect with them.
From last 5 days I am searching anyone, but I didn't find anyone on LinkedIn.
You see the names here, right? Just try to search, because we don't prefer that batching, right? Or because in that way things becomes more difficult, because
sir जो हमारा डाउट क्लियरिंग मतलब वो है ना 6 से 12 तक, मैंने ना 3 बार उसमें ये किया था, लेकिन हर बार वो जो सर आ रहे हैं वो बोल रहे हैं कि हमें हाइव के बारे में कुछ नहीं पता। तो सर से मैं बात कर रहा हूँ 3 बार, और वो हमारी बात सुनने के लिए 1 घंटा वहां पे रुकना पड़ता है। तो 1 घंटा रुक के वो सर ऐसे बोलते हैं कि हमें कुछ पता नहीं है हाइव के बारे में, तुम इनको मेल करो या तो तुम उनको मेल करो। तो और वो डाउट तो बहुत छोटा रहता है, समटाइम्स हमें वो यूट्यूब पे या गूगल पे नहीं मिलता। तो
so see, whatever you have, right, just keep on sending to me, right? Not an issue. जो भी अभी है, just mail it to me, right? From my side, maybe मेरे को 1 दिन लग जाए क्योंकि काम रहता है, तो मेल जैसे चेक करूंगा, I will respond back. So expect some delay, but you will get a response in some time. So whatever is the query, just share it with me.
ओके। एंड सर लाइव लेक्चर में मतलब जो क्या बोलते हैं हम, मैसेज सेंड करते हैं, वो भी नहीं पढ़ सकते मतलब?
I keep on reading it, right? I keep on reading it. That's how I answer it.
ठीक है सर, ठीक है। वही सिर्फ मुझे यही बोलना था कि मतलब हम एक दूसरे के साथ इंटरेक्ट करेंगे।
मैं रीड करता हूँ तभी तो मैं आंसर
आप नहीं सर, आप नहीं, आपकी नहीं बात कर रहा, हम नहीं रीड कर सकते क्या, ऐसा बोल रहा हूँ। आप तो करते ही, आपको दिखता ही होगा ना। हम मतलब
move on to next question, Omkar. Let's other people talk. और शेखर?
Hi, Shashank. Am I audible?
Yes.
Yeah, just a small doubt from one of the previous sessions actually. So Shashank, when we load our data from the HDFS to Hive table, then basically the data will be moved, right? The data won't be present at the same location then.
Right.
But in case of local file system, it won't be moved, right? It would be just copied. The data will remain in the LFS, right? No?
Correct.
Just this was the doubt actually. Yeah.
Okay.
Thank you.
Cool. Saurav?
Yeah, hi Shashank. Hi.
Hey.
Am I audible? Yeah. Okay, so first of all, when we were writing the function, right, UDF, so initially you saw that we saw that we were passing 1 parameter but giving 2, and it was throwing an error because internally we were not catching those 2 parameters, right, and we were not doing the functionality there.
Right.
So whenever suppose we are passing 1 or 2 or multiple parameters, and we are typecasting there like before writing to string, and then in the outside also, like in the select query also, we are typecasting it. So can we not do it in one place, either in the UDF or if
No, it will not be done. It will be always done outside, right? From the outside means in that select command. Internal in Python, it cannot be done because that output will be returned as a stream. So it doesn't matter if you convert it or not, but that will be not doable.
Okay. So my next question will be like in the bucketing, when we are doing the sorted by thing, as in partitioning, we previously talked the order by and sort by. So order by does a global kind of thing. Can that also be applied here? The global order by thing, like order by in the global scenario where one reducer was doing the whole order thing and we were getting one partition for that only. So in the bucketing also, can that be applied, like order by global thing, right?
Yeah.
Okay. So the next question will be like Hive, as you say, like Hive is internally doing the bucketing for us, right? So according to some hash hash scripting. So is there a way, like if someone wants that I need this bucketing to happen in this particular manner, so that the hash script can be user defined or something and then can be used?
That can be checked. I mean, as of now, like how explicitly it can be defined, because from the programmative perspective, I don't think so that will be doable. But if let's say Hive supports different hashing properties, so that can be checked, which one needs to be enabled and which one gives more better result.
Okay. So my next question will be, so suppose like in the joining part, when you said like in the left hand side we have so suppose like few buckets where some keys are there. In the right hand side, so the example of 4 and 2 buckets, right? Like 4 buckets are having 1 2 3 4 5 6 and 8, and other one was having 1 2 3 4 and 5 6 7. So will there a scenario arise where, like suppose in left hand side bucket we are having suppose like 1 2 3 4, but in the right hand side there will be 2 buckets suppose, and the keys that are required to send to the left hand side bucket will be present in more than one bucket in the right hand side, like so that the 2 buckets needs to be sent to that particular thing.
So yes, that is how it is done, right? It's not always one bucket is there. So depends on, because that is why the like those number of buckets should be multiple of each other, so that the full part can be shared. So if the mapper task which is processing more than right that way, so those 2 buckets will be sent to one mapper task, right, where like all those keys which has the same hash values, right, can be joined together. It is not just only at the one bucket, but the good part is that maximum time the mapper will be doing the concurrent processing on different blocks, right? So these buckets are also very small enough, so that is how the concurrency will be increase the parallelism, and there will be no issues on the out of memory, because if those buckets or those are very huge enough, and that will not fit into the memory, and we won't be able to do the joins.
Yeah, so in that case scenario, sometime it might also happen, like suppose there are 3 buckets in right hand side, so 1 2 is getting sent to one mapper, and again 2 3 is getting sent to, so 2 is repeatedly sent to different mappers also, right?
Yeah, so whatever bucket will be required, so every time at least on each mapper you can see the whole data set will not ever be required, because whatever type of keys there which needs to be joined, only bucket corresponding to that will be sent to the mapper one.
So does Hive internally check this, like from
everything will be taken care by Hive.
Okay. One more thing I faced, like not in like this practical, but like while working with TCS. So when we are storing, like we are partitioning and storing in the storage explorer of Azure. So sometime when suppose partitioning on some column, and that column is having suppose 1 or 2 null values, right? So there it showed it was showing that other partitioning was generating suppose like partition equals to like the
so
country.
Null shouldn't be there. Null shouldn't be there.
Yeah, in that case actually it was generating something called Hive default partition or something. So, and that was not, we were not able to query it in the database actually, the default partition thing actually, which was generated because of the null issue. But the other partition, like suppose country equals to USA, country equals to Australia, those we can query, but country equals to Hive default partition thing we were not able to query actually. So, so should we in all case like apply it in such a column where no null values will be there?
Yes, that is the best practice.
Yeah. Okay, thanks Ajay.
Okay, Surya.
Hi Shashank sir.
Okay.
Sir, my doubt is, sir, am I audible?
Yes, tell me.
Sir, my doubt is regarding assignment. Have a doubt, like I'm not able to write the query for the last question that you have asked. So, can you help me on that part?
Not at this moment, but whatever is there, share it with me. I will send the solution over the mail.
Sure, sir. And I have a general doubt, like while we create a table, we created after giving the schema details, we use row format delimited. So we don't explicitly mention any hyphen /t /r or /n.
So that I always write the second line, fields terminated by comma.
Yes, sir.
So that's the answer for that one. So row format delimited, this is to notify the Hive that something, the data is coming, at least some sort of delimiter will be there.
Okay. So the delimiter will be automatically taken by Hive, or
how it can be taken care by automatically Hive? We are providing it in the create table, right? This is the delimiter. And when I talked about the CSV surveys, then there were multiple properties. We could have set the code character, the escape character. If our input is in not a proper CSV, means some columns which can contain the delimiter as a value itself. So if we have a normal CSV, it can be read with that one. But if we have a custom CSV, in that case, we need to use the CSV survey.
got it, totally.
Next, Shri Kumar. Hello. Shri Kumar. Hey, Shri, I can't hear you. Anyways,
Hello, sir. This is Surya. Sorry to disturb, sir. Where can I share the query with you?
over the email, shashank@ineuron.ai.
Okay, sir. Okay, sir. Thank you.
Mahatesh. Hello, Mahatesh.
Yeah, hi, Shashank. Can you hear me?
Yeah.
Mantesh here.
Yep.
Yeah, thanks for the. Today I couldn't attend completely. I was in hospital, so I have one doubt. So how we can recommend Hadoop only? See, I mostly worked on a Snowflake and other DBMS. But compared to Hive, right, how much I explored, I feel Snowflake is much more faster, or compared to easier, or even the way it works, right, smoothly. I don't feel Hadoop is that much, but still it's like an open source, and how competitively it can save the money of an organization. Any little bit detail comment on this?
What you are asking with respect to Hadoop, whether Hadoop is being used or not? What is it, that question?
No. See, if some organization is using enterprise solution like a Snowflake or something, it's totally free, right? And it's like if we have set up everything, then how it can save the money of any organization? How we can recommend? I mean, it's a comparison between the other enterprise.
So see, that is something which will keep on changing, right? That will be a debated topic. Not everyone want to use the Hadoop. Not everyone want to use the Snowflake. If company can spend that amount of time, because when these enterprise tools
No, I mean, for example, just cost-wise, right? Cost-wise, for example,
cost is also there, but support is also something which is important. So let's say for the Snowflake, correct? Or I'll take an example of AWS. So in AWS, let's say I have purchased Redshift, correct? And we are using it extensively. At any point of time, if we need something or any functionality which is still not available for the open Redshift, but I can just pitch this to the AWS team that we need this functionality on the urgent basis. They will do it on priority. So cost is one thing, but another important part is the support. Support we get from the enterprise tool, the maintenance, and the time to enhancement they keep on doing.
Totally agree, but I'm just asking cost-wise, which will be lesser?
Obviously, the open source will always be lesser in terms of the cost, right? No comparison. There is no debate on that one, whether the Snowflake will be cheap or the Hadoop. Always Hadoop.
So for example, for 10 TB data maintenance, how much it will cost?
Sorry?
Just an example. For 10 TB data maintenance, 10 terabyte of data maintenance, how much it will cost?
The Hadoop part. So Hadoop part is something that is something application you need to install. You need to majorly invest on the infrastructure. So that will depend on your company. Okay, what kind of on-premises, how many servers they are using, the RAM, SSD, what is there, the configuration of it. So I cannot comment anything on the exact number. Okay, this will be the exact cost, because that is something your company is bearing in terms of the infrastructure setup.
Correct. Okay. Okay. Fine. Yeah. One more thing, Shashank. So this Hive challenge with Shashank, right? And to say when the challenge gonna end, and I think you mentioned this weekend it will be end, and you mentioned there is a prize also. So I'm just curious to know the result.
It will be, and we will announce the result. So maybe not maybe Sudhanshu, but if it goes to the next week, so I will be announcing it. Don't worry.
Sure. Thank you very much. Thank you.
Yeah.
Hello. Hello.
Hello.
Yeah. Hi, sir. My name is Sri Kumar. I've been in the new batch of this big data. I was going through the videos. I need help setting up the Hive. Is it possible to set up on my own PC?
You can do it.
Because you most of the things you're doing, and then the cloud environment is not available, right?
That cloud environment is about to release in 1.5 weeks. So if you can wait till that.
Yeah, no problem. That is fine. But the thing is that I would like to practice on my own. Is it possible to do it on my laptop? I don't know what the exact.
Sudhanshu has given all the lectures, and it's an easy setup process. If you listen to first two videos, it is like more than 1-2 hours. You can set up your own. But,
okay.
Yeah. I think you missed the first two lessons.
Yeah, because fine. Thank you, sir. I'll go through the video. But if in case I face any problems, is there any support to help me?
Yeah, so you can contact the support team, right? Even in your dashboard, you will see there, and you can connect with the technical team as well. And if something else, you can even mail it to me.
All right, fine. Regarding today's topics, again, I understood the bucketing, but I don't. The word is so common with the partitioning. I didn't see what exactly bucketing gives you. Means even for the partitioning, you give order by means partition by some column. The same thing you do it for bucketing.
Clustered by. So I explained these things, right? Where precisely you need to use the partitioning, where you precisely need to use the bucketing. I thoroughly explained it today.
But
maybe if you didn't get it in the live class, just watch the video on repeat. I thoroughly explained why, when this bucketing was required, how this partitioning and both things are different with each other. I thoroughly explained.
Okay, I'll go through the class again. No problem. Means I means maybe I didn't get it. I'll go repeat.
Watch it. Yeah, if you don't get it, then ask it in the next doubt session. Yeah.
All right. Thank you.
Akshit.
Hi, can you hear me?
Yeah.
So actually, I'm in my like when I'm trying to upload the CSV files through FileZilla, I'm having an error. Like sometimes it's a random error. Like sometimes it's not able to read the whole data. So like some rows will be missing, but it only happens when I'm trying to create the CSV on my own. It doesn't happen on a like pre-prepared CSV. So is there a resolution for that? Like, or can you give me the reason why this is happening?
So how you are creating a CSV and where you are creating it?
So CSV is like in my notepad.
Okay. And you are saving it, and what it is saying in the error?
So it's like not an error. It's like sometimes it's some random things are happening, like some rows are missing, like sometimes some extra like
so
delimiters are there.
might be you You can check on the delimiter part and you can check on the new line character if while creating it you had something or you copy pasted in such a way that some garbage characters, right, which got added. So that could be also one of the issues, right? It is reading incorrectly. And
But I even
the
tried
way,
to.
let's say the table, the sequence of column you have mentioned, and even in your input file, the data types and sequence are in the same way.
Okay, okay.
Also, maybe in
I'll
the source
I'll
file,
share you the.
maybe adding the extra nulls records.
No, actually, even after copying the data, I tried to copy the data directly from GitHub. So like exactly the file from the GitHub, but still I was getting. So it's a random thing. Like sometimes it's working, sometimes it's not. So I was not sure what's the error. Anyways, I'll try to fix fix the
Maybe
by what
the
you're saying.
CSV file you created, right? You can send it to me, right? I will try to open it in my notepad and I will open it in my Sublime and will try to check like why it is breaking.
Okay. Okay. So actually previously all my CSV files are opening in Excel, but then I changed it to
No,
Notepad.
never. Just make a good practice. Never open CSV files and all in the Excel. Just always prefer Notepad and Sublimes.
Okay.
Never ever. Yeah.
Even Notepad plus plus is good. Hidden values also can be shown.
Yeah. Next, Tishmul.
Sir, thank you, sir. Yeah, actually, I have you would have answered this. Just wanted to clarify it. In map side join, each mapper will process specific set of data, right? So, how I will decide like this much amount of data this particular mapper should process? Is it something Hive does in the backend or?
No. So that will be depend on the block size, right? HDFS data will be in the HDFS, right? So when you load the data in the Hive table, it goes to the warehouse, which is HDFS eventually. And when you fire a query, eventually everything will turn out into a map reduce. And number of map tasks will be equivalent to the number of blocks you have. And for that one, we set the property while installing the Hadoop, right? There is a property block size. So in Hadoop 3.x 128 MB. So those number of mapper tasks will get scheduled.
Okay, thank you. And last question is that you said like each mapper will process specific set of data based on whatever types of key, right? So what is this key called? I don't get that.
Sorry, can you repeat?
So you were saying while someone was asking, like each mapper will process specific set of data based on whatever types of key. So what is it?
I was explaining with respect to the joins, right? So join, there will be join keys, correct? And if are the join keys, so data will be moved to different, because data will even get stored in that manner because it will be bucketed. So it will be moved over the mapper reducers based on the keys. The values were hashed, right? In your buckets and partitions.
I just don't get that keyword. What is it referring to? Is it like a dictionary key or what?
Not a dictionary. So let's say if I have a 10, right? And if I divide it by 2 or I take a mod of it, so it returns me 0. And if I have a reducer whose ID is 0, or that is something internally taken care by Hive. So based on that hashing one, okay, it will decide in which bucket it needs to go. And when, right, you do the joining and all those things, wherever your mapper tasks are running, Hive will take care of it. Okay, in which mapper task I need to send this bucket.
So that hash function will return that key, right? Key.
Yes, there's some value. Yes.
Okay, that was it. Yeah. Thanks, sir. Thank you. Yeah.
Okay, Margam. Hello, Margam. Margam, can you unmute yourself, please? Anyways, Ayushi.
Yeah. Hi, Shashank.
Hey.
Actually, I just have a very small doubt. I was just trying that Python UDF script. So what I can see that when I'm doing just a Python space in the file name, it is taking me the input, but it is not providing any output. Like if I am going to give it 10, it is not giving me 100 or kind of thing. And the same thing what I'm doing, I have done the add file in Hive, and then I am running that select command. It is running, okay, but it is giving me very strange output. It is giving me the values, proper quantities, but in a just a parallel column, it is giving me the null values as well. I'm not understood why null values are coming. If you want, I can share my screen as well.
You can send me that one, Ayushi. Again, I would say the same thing to you. What you can send me the screenshot of the script, right? And you can send me the screenshot normal, right? Where you are saying you are running the Python. You typed terminal on terminal Python space your script. Send me that output. What is happening there? So just share those screenshot. Most importantly, the script one. I will exactly copy same script at my end, right? And will quickly run it. If it is working for me, it should work for you as well.
So, can I tell one thing here? Actually, I think the version is the problem in Python. Just check for the version what it has.
Yeah, I have checked the version as well, and it is 2.
Yeah, I think it
So
will
go for
show.
Python 3.1. Yeah, good point.
Yeah, I have checked the version. Yeah, it is 2. So I have to install
Install
the
Python
update.
3.7. Yes.
Okay, fine.
Yeah, try that out. And if after that doesn't work, just then share it with me.
Yeah, sure, definitely. Yeah, thank you so much, Shank.
Yeah. Margam?
Hello, sir.
Yes.
Hello. Hi, sir. Good afternoon.
Yes, please ask your question.
So this course, I enrolled in this course 4 days back. I'm in 4th year, so I just wanted to know how to start. Some assignments are also given.
So for this one, you need to start from the beginning, right? In your dashboards, all the recordings for the previous classes are there, date by date, right? Everything is there, and whatever I have taught so far, including the assignment and including the reading material, everything will be present at your dashboard. So from there, just start catching up.
Okay. Any prerequisites to know before this?
Prerequisite, everything we have covered from the scratch, right? Even installation and all those things. So nothing separately needs to be talked about.
Okay. And about the assignments, any deadlines?
So assignment, since you have joined, right? There is no deadline for you, at least at this moment you have joined, you need to catch up. So just go at your own pace, and probably for the moving forward, the new modules, right? We will be having there. When you catch up, you can submit the assignments on time.
Okay, sir. Okay. Thank you.
Cool. All right. So thank you so much, guys. Thank you for joining. I hope everything is sorted out, and the script which I ran today for the sorted merge join, all those commands will be updated in the GitHub. And second thing, the assignment you need to work, or the mini projects for the Hive, those two will be also shared with the team, and you will be able to access it, and you need to complete those 2 assignments as well. Cool. And as I said, the next one class, tomorrow's one, will be taken by Sudhanshu itself for the HBase. And yep, that's what I had. Thank you. Thanks for joining.
So next class you want to take, which will be your next classes, Shashank?
It will be tomorrow by Sudhanshu.
No, you will be covering what all topics?
Yeah, I will be covering like so many components. Don't worry about it. I will be coming with Kafka, PySpark, SQL, Cassandra, AWS, and many other stuff. I'm not going anywhere.
Sure. Yeah. Thank you for the info.
Yep. Bye-bye.
Bye bye. Have a good day. Have a good weekend.
Hello, sir.
Thank you.
One doubt.
Yes, tell me.
So if I get any troubles, any issues, do we have any channel to post?
So in the dashboard, you will find a link for the support team, right? You can just connect with the support team, technical or any kind of issue, they will help you out.
Okay, sir. So regarding technical, right, like
Yes,
installations,
both,
yeah.
both, everything.
Okay, okay, sir. Thank you.
Bye.
Bye bye.